how to build a Python snake game. Now, wait, how do I say this? I have a guest here by the name of Michael Lecomte, who's actually a team member here at Clever Programmer. He knows Python. He does a lot of things here at Clever Programmer. But I will let him introduce himself to you guys because he is an epic dude. He's an amazing guy, a hard worker, does not stop, and just an amazing teacher in general as well. So guys, hold on, guys, give it for Michael. Give Michael a round of applause in the comments for Give him a round of applause, and I'll let Michael introduce himself, guys. So, Michael, introduce yourself, who you are, and yeah, what are you doing here?
Awesome, man. Appreciate the introduction. Yeah, dude. So, I guess I'll start off by saying that originally I was actually a profitable shortcut student. So before I ever worked with you guys, as you know, I used to be a student here, and because of profitable shortcut and because of Clever Programmer and Profit with Python, I was able to quit my job. I was able to start freelancing and make my own money. And it's been an incredible experience meeting all of you guys. And today, what I want to go over with you is a little bit about my business and what I do, and what I do is tutor people, but also the main thing that I run into when people are trying to learn Python. This is the biggest thing, and they always tell me there's if statements, there's for loops, while loops, and we can write all these things in a row, but it's like we're told let's make a website, let's build this app. And then the second that happens, you think to yourself, I have no clue how to do that. So I'm going to go over today a little bit about how you take an idea and put that into code. And we're going to do that with a really cool game that's called Snake. It's a classic. And we have an example here, actually.
Well, before we get into the example, guys, so like I said, guys, welcome to the stream. Welcome, everybody. As you guys are coming in, a lot of you guys new are coming in. Just wanted to say welcome. Today we are building a snake game, and I have a guest here, Michael Lecomte, who's actually a team member on Clever Programmer. He's an amazing guy, hard worker, just a crazy guy. He's just like the doer and a great teacher as well. And he knows Python, I know, too. So with him, he's going to be showing us today how to build an awesome snake game, but most importantly is how to take an idea, right, and actually put it into something that's useful, right, guys? So I know we had a small issue with the stream before, but looks like it's all fixed, which is awesome. So guys, for that, give us some fire, give us some rocket emojis, and welcome to the stream. Welcome to the stream, guys. So hold on, I'm gonna do this. No, can you see this? Can you hear this? Hey, you can hear that, right?
I should get a soundboard. That's awesome.
Yeah, I have also this applause, yeah. I don't know if you can hear that part.
That's fantastic.
Oh my god! So we have so many people coming in. It looks like we have Steve. Steve says seems fine now. Let me move this over. We have Steve. We have so many people coming in. Oh my god! Sayuri, what's up? We have. Yay! A lot of people are saying, yay, it's all working, which is oh, that's so good to hear, finally. Finally, awesome. It's working. Guys, let us know down below, where are you guys coming from? Where are you guys coming from? We have people from so many different countries who are joining us, and it was always awesome to know where you guys are joining us. Melanie says, woohoo, let's go, Melanie. Let's see who else we got.
And real quick here, man. Let's if you can send me the link for this new stream on YouTube, I can post it in our previous stream so people know where to go.
Beautiful. That's a great idea. It's a great idea, Michael. Michael's the man. That's why Michael's the man. There you go.
Awesome, man. Thank you.
Sweet. Who else we got, guys? Looks like Karin is coming in from Switzerland. We got from Montreal. We got from Iran, from Ghana, from India, from somebody said Earth. Somebody said I'm from Earth. I mean, that's good if you're from Earth. If you're not from Earth, that'd be interesting, actually.
Welcome.
That would be cool. Yeah, welcome to Earth. Welcome to Earth. Somebody said, Suman says Nepal. Oh man. Hello says I made a snake game in C++. Guys, so who's excited to make a snake game? Who's excited to make a snake game with us in Python and actually have it be running? It's actually so much fun. Michael just showed it to me and it looks epic. I am not kidding here. Seriously, like not even a joke. Somebody said I'm from Mars. That's okay. That's cool. All right, that's welcome. Maybe you can give us an invitation one day for us to go to Mars.
Right. I'm curious how they got reception out there.
I know. How do you get reception on that? That's some very high. That's some very strong internet. We got from Bangladesh, from Tanzania, Tunisia, from Kenya. Wow, 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 wow. So many amazing people. Guys, so many people. Wow. I love it. I love it. The interaction is great. Somebody said, I'm from Snakeland. I don't know what that means. I don't know what that really means. But cool. Awesome. If you're Snakeland, okay. So, guys, actually, for those of you new who just came in, I just want to have one last introduction. That is, today we are building a Python snake game, okay, with Michael here, who's one of our guests, and he's actually a team member here at Clever Programmer. So if you are new, give him a round of applause. And with that, we can pretty much get started. But before we get started, Michael, do you know what they need to do? Michael, what do they need to do? Do you know?
I do know.
What?
I think they need to smash that like button.
Hey.
Also, share it with all their friends.
Exactly. So you see there's a button down below. It says like a thumbs up. Here's what I want you to do. I want you to click that pointer. I want you to drag that pointer all the way to the bottom, okay, where it says the smash it. I know you click it like a lot of times, but click it so that it's blue, okay? Make sure it's blue. And then make sure you obviously click subscribe, and then we'll all be good. And then obviously share this stream on Facebook anywhere you got, and we're going to be pretty happy with that. Sweet. Michael, let's get started. Let me go ahead and bring out the presentation, guys. Let me bring out the presentation so you guys can see what we see. And hold on, let me see your comments. Let me see what your comments are. Thank God it's all working. This is good. This is good stuff. All right. We had some issues, but now it works real good. All right. So here to code, Michael. You see what I see? Yes, you do. All right.
Absolutely.
So here to code. So Michael, give us a rundown. Now you're the guy here.
Absolutely, man. So the number one thing I want to introduce here is the idea that, we run into all the time as teachers, right? What we do for the entirety of Clever Programmers, teach people how to code. And so time and time again, what we run into, the same issue we run into is, I understand if statements, I understand for loops, I understand while loops, I can write things in order. But I don't understand when somebody tells me make this game,
right.
Even if it's a simple random number generator game, or if we build a simple website, the common thing they run into is I have no idea how to put these things together.
Right.
So today I want to introduce to you an idea that's called software architecture, which sounds really fancy and complex, but it's actually really simple. And what it is the process that we use to take an idea, break it apart, understand how the data works there and how we're representing our game or our website or all these things, and then use code to actually implement that idea.
Yeah. So guys, drop in the comments below. This is actually one of the biggest challenges that a lot of our students have, in Profit with JavaScript, in Profit with Python, right? They ask the questions, right? They learn all these things, but then they get hampered with the question of like, I do not know how to get started. Like yes, I can build things from a tutorial, but when it comes to actually building something basically from scratch, taking an idea that you have in your mind, maybe that's building some kind of an app or anything, right? It's always hard. And the reason why it's hard is because you guys do not know the process it takes so that you can kind of build this idea, so you can spread that idea into smaller parts and actually get started. So drop in the comments below if you have that same problem, which is being able to start an idea, being able to start a project all on your own without anybody's help. I want to see it. Drop that in the comments below. But Michael, continue on.
Absolutely, man. So let's move on to the next slide here. And I want to talk to you a little bit about, what we have is the common thing people ask is, Python, JavaScript. Now, don't get me wrong. It is really important for people to choose the right language for the right job, right? If you're working in the web, the biggest thing is JavaScript.
Yeah.
If you're doing data science, the biggest thing is Python.
Yep.
If you're going to make a AAA game that has all these graphics going on, you probably want to do like C++. So the right language for the right job, absolutely.
Right.
But the biggest thing that people miss, again, and I want to reiterate this because I found it to be so important, is that it's not about Python or JavaScript or any of these things for building the apps. It's about thinking, how do I take this problem? How do I define its behavior, understand how it works, then break that up and turn it into code, right? This process is universal for coding.
Yep.
It's language agnostic. And so this is the process I'm going to teach today. And what's really cool about this is that by the end, you guys are going to be able to play your very own Python snake game. I'm going to teach you all how to set it up. You're going to do it in your browser. You don't have to download anything. You don't need any image assets.
Yeah.
It's going to be awesome. It's going to be awesome.
Sweet, sweet, sweet. Now, guys, just for the fun of it, I'm just very much curious. Guys, Python, or I know you said it doesn't matter, but I'm just curious, who here is more interested in learning Python and who here is JavaScript, more of a fan of JavaScript? Drop that in the comments below. Let's get some competition going. I always like that. I always like that. But obviously, like Michael said, right, doesn't matter. What matters is basically what the demand is. So if you have a job that needs Python, you should be learning Python. If you have a job that requires JavaScript, you should be learning JavaScript, right? But there's still some, dude, everybody's like Python, Python, Python. Come on, guys. Nobody here with JavaScript? What is this, guys? Come on. Give me something out
You're
here.
dying breed, Oz.
Come on. You know I'm a JavaScript guy. Python. Python. Oh, somebody said both. Thank you. Finally.
Absolutely,
dude.
man.
Everything is like. Oh, hold on. Somebody said JS. Siva, thank you so much. Finally, thank you so much.
There we go.
Sweet, sweet, sweet. Python, Python. Oh man. Guys, not cool. Come on, but I mean, it makes sense. Everybody here is we're coding in Python, so it makes sense. It makes sense. But anyways, guys, one last thing before we get started right away. Make sure that you go ahead and tag us in your Instagram. So make sure to tag us in your Instagram right now. Literally, I want you to take out of your phone right now. Take a picture of us right now, and literally tag Michael. You see Michael right there. You see Michael's what's it called? Michael's Instagram is right there. Mine is right here. So you can literally just tag us in your photo and be like, yo, let's learn some Python. Tag us on Instagram and let's keep it going. Sweet, Michael. All right, let's continue on.
Absolutely, man. So now I want to talk about, like I said, it's more about software architecture, but I want to give you guys a taste of what we're doing today. So we're just going to kind of jump into the code first a little bit and see what's going on. And then I'm going to start to build this app with you guys. We're going to talk about why I made some of the choices I made. And I'm going to essentially give you the system that I use, the step-by-step system that we go over in Profit with Python at our Clever Programmer course. We're going to talk about exactly how we do that, and it's going to be awesome. So let's look at the Snake app here.
All right,
and talk about
the one that's already created. Are you talking about the one that's already created or this one?
the Snake, not new Snake.
Okay, let's go. This one right there, right?
Yeah. Yep. And what's cool about this is we should be able. Let me try and run it on my side, and it should stop and run for you. Let's see if it does. Awesome. So I can play it on my side. So what you're going to see right off the bat is we have this really simple, oh, I stopped it again. Here we go.
Hold on. Guys, how cool does this look? Give us some fire down in the comments. Damn.
So what we have here is a menu screen, and it's just a little simple wormy thing. You can press any key to start the game.
Oh, wow.
And you can control it here. So as you can see, it's an awesome, this is a classic. I don't know if you guys had this on your flip phones back in the day, but I used to play this thing all the time.
Dude, this is good. This is good stuff.
Now, I could sit here and play this all day. Actually, I have a problem with Snake.
This is
what you'll see
awesome.
is we have a game over, and we can restart the entire game. Every time it eats an apple, it gets a little bit longer.
Nice.
And we're going to go into exactly how that's done.
Wow, that looks cool. Guys, who's excited to build this? That just looks awesome from the get-go, man. So yeah, who's excited to build this? Let us know in the comments below, and we're going to build this. Shall we start? Or wait, actually, no, you run this. So what should we do next?
Absolutely, man. Yeah, so let's see. I'm excited to see. I'm looking at the comments right now, just seeing what people are saying here.
Somebody asked, are we going to make this game using object-oriented system, object-oriented programming?
We will, yes, we will.
Beautiful.
We will. Now, funny enough, if you look up online, you'll see a lot of tutorials where they just kind of split it all down in one page, one huge page, like 400 lines, just to make this one game in one page. What we're going to do is split it up, not only object-oriented, but we're going to talk about why. Why do we do that?
Yeah.
Because I feel like that's the biggest problem we run into. So this is awesome, guys. Again, we're going to go over exactly in depth just a fraction of what we cover in our profitable shortcut or our profit with Python courses.
Mm-hmm.
And I would highly recommend you do that and follow along here. And let's get started. By the way, I don't know if we have the link here. Do we have a link set up for our profit with Python? Let me get this for you guys because this is really nice. This is a course that we do. This is the course that I took and I quit my job with. It's absolutely awesome.
Oh, dang. Shall I show it to them? Shall I show it to everybody?
Absolutely, yeah. Just throw that up on screen real quick and then we'll jump into the code here and keep going.
There.
Awesome. Yeah, so just send that, maybe put that in chat or something for them so they can click on it.
So you guys, for number one is you guys. So actually, before we do it, let's go ahead and explain what this is before we do that, Michael.
Yeah, of course. Yeah, so this Profit with Python course that we do is our in-depth, step-by-step course where we go over teaching you from knowing absolutely nothing about Python to being able to build clones of some of the coolest apps that we have. Absolutely awesome. One of the best parts about this program is that you could take so many courses, right, where you kind of step through and by the end it's like, okay, I built some cool stuff, I feel a little bit more confident. But not only is our content absolutely awesome, this is some of the best Python training stuff we have. You're going to get access to somebody who's going to train your code live. And by that I mean they're going to work with you and look over your code and say, hey, like this is what you could do better. This is how you can improve things. This was one of the most helpful things for me. Now, also, we have weekly live training calls, as it says there, and you get community access to all of the awesome people we have. This is one of the most powerful things.
Yeah. How many members?
Was some of the friendships I got from this.
How many members do we have in that community right now? Like a lot.
It's huge. It's
huge. I think it's over 1,000. I think at this point, over 1,000 or something. Guys, it is beyond anything else. Like the community is one of the biggest points between the community, between the training. Like if you're looking for something where it's, this is not just a course where you are simply going to be, going there and going through videos. This is a breathing and living course. It's basically a boot camp. Like you go in there, right? You have a community of people who are helping each other, right? Through Slack. You have Python training calls, right? Python training calls by one of our amazing guys like Jacob, right? So you're gonna be learning through that. On top of that, you have the Python training modules, right? You've got your success coaches. And Michael, can you explain what a success coach is, what they do for us?
Yeah, man, the success coaches, like I said, are probably the most important part for me.
Yeah.
It's one thing to watch a tutorial and code. It's another thing to do that and submit that code and have somebody look over the code and tell you, this is what you did. How could we do this better? And this is what you did really well.
Exactly. And they're going to be there to help you every step of the way. If you've got any questions, they're going to be there. If you have any suggestions, they're going to be there. They're always going to be there. They're haunting you. Well, not really, but you get my point. So, yeah, and most importantly, I think the really important part is the earning a killing with Python. Can you talk about that for a second?
Absolutely, man. So the biggest thing that people want to learn Python for or JavaScript is that the reason they do this is, maybe they want freedom, or maybe they want to make a bigger income for their family, or maybe they want a side business. Most of the time, right, people want to use these skills to do something and make a real impact.
Yeah.
And it's one thing to learn it as a hobby, and that's fun. It's another thing to take those skills and to be able to make an actual difference in your own life, like I did, and with the help of this course. So
exactly,
that's the biggest thing, is that we're not just teaching you the skills about how to do Python. We're also going to help you figure out how to use those skills and make a real difference in your life.
And make some money. Exactly.
Absolutely, man.
Exactly. So you can see, obviously, one of our instructors, obviously, Qazi, right? You know Qazi. You guys know Qazi, right? What's up, Qazi, if you're watching? Yeah, you guys know Jacob, right? Obviously, Jacob, is our Python coach as well. We've got 2,552 students, which is crazy. And obviously, we have a lot of testimonials coming through here. You can take a look at them, and then you can take a look. But one really cool part is, one thing we didn't mention is 100% guarantee, so risk-free guarantee. So if you don't like it, on the 29th day, 29th hour, actually no, 23rd hour, 23rd hour, 59th minute, And in 59 seconds, you can pretty much just return it, not a problem, right? So yeah, guys, check this out. The link, where's the link? The link is in the description under this video or above this video, somewhere around here. Actually, it's below this video in the description. Take a look at that. We'll also post the link to this one in comments so you guys can see it as well. Right there. This is it right here. I just posted the link in comments. So guys, check out the link. Go on there, check it out. And if you're interested, if you're interested, I mean, you guys should be interested because you're out here to learn. Is that not right? You're out here to learn because you want to become developers. And this is one of the best ways. This is one of the best programs that we got to help you do that. Sweet. So on that note, anything else I should say?
No, man. I think we should get into it.
Let's get into it, bro. Let's get into it, guys.
Okay, man. Awesome. So let's switch over to our new snake here. And what you're going to see is way more code and way less functionality. Yeah. And this is going to be an ongoing theme here. We're going to talk, like I said, a lot about the architecture of how we build things. But if I give this a run, what you'll see here, and this is just a basic thing that we do with Pygame. We have, number one, a display surface. So we import Pygame. We import our pygame.init. So what this does is it sets up the game for us. And these kind of settings here, this sets the window. So this is called a tuple. And it's essentially a list, but it can't be modified. So we have 800 and 600 here. That's the width and the height. We're setting up some fonts. We have a game clock, which allows us to track how many frames per second that we're going to put on the screen. This is the title of the window. And then we get into the real meat. So this was like the setup, right? We haven't really done much yet. We just kind of set everything up. This is where things get really interesting. The biggest thing in the game is the game loop. So what the game loop is the thing that essentially continues to run and provides for us the context of the game, right? Yeah. We're running and there's states that we're managing and we're worrying about, when is, for our case, did we eat an apple and grow? Did we turn the corner? Did we hit a wall? Things like that. Yeah. So this is the loop that continues to render the game. Yeah. Now,
so a loop from understanding, it's like loop is kind of like, think of it as life, right? You have, time that's going by, for you as you guys are living. You have a time that goes by every minute, every single second, right? Every second counts, right? And something's happening every single second. Same thing here, except in coding, right? You have a while loop. So you have to think about the while loop, right? A continuous while loop, which is basically where this is where your game runs. Your game runs continuously every single second, and this is where you make the changes on any changes that happen. To maybe you pressed a up button and you want to change the view, right? Maybe you press the down button, right, and you want to change that view. So that is what the while is there for. But anyways, let's keep going.
Absolutely, man. Absolutely. That's a great way to think about it. So in this is where we continue to change the state of the game. We draw the graphics of the game. And this is where the game happens. Now, there's only two things I'm monitoring for right now. So number one is Pygame. So if I highlight this here, perfect. You can see that. Yep. Pygame gives us this event.get function. And what this is it's going to give us an array of all the events that have happened inside of that loop, essentially. And so we go across all the events and we say, okay, if we have an event of type quit, that means we want to close the window. Now, something you guys probably didn't realize is that you actually have to add this. Otherwise, you can't close your window and it just runs forever.
Oh, nice.
Right. It's kind of funny. Something you wouldn't think about. Now, another type we're looking for is if the event is a key down. So now we're pressing on buttons. Right. And we're monitoring that. And if it is a key down, we also want to check, okay, if it's an escape key, we're going to quit the game, exit the program, all is done. Right. Now, if none of that happens, it's just business as usual, right? We're doing the game, we're moving the snake, etc. So all I do is I say, okay, let's make everything white. Let's update the display. And then this is the clock tick function allows us to essentially have a speed or a time during the game. Right. And we'll kind of get into that in a little bit here. But all this code, right? All this code, and all we get is a white screen where if I press escape, it goes away. Versus, and we'll take a look here. Go ahead and go to our original snake. And if you go to the main file, because of how we've set up our code, all we have is 3 simple statements. We create a game, we run a game, and when the game's done running, we quit.
So, Michael, I'm actually very curious. How can they follow along? Can they follow along, or will they have the code after? Like, what can they do to actually build something like this as well?
Yeah, absolutely, man. So let me go ahead and post that in the chat real quick. We have a few options for you. So number one, I'm actually going to give you guys this link here. You can watch live, and if you start coding, what's really cool about REPL.it is that it'll do what's called a fork. So essentially copies everything into your own little directory, and then you can start playing around and coding along with me.
Yeah. So guys, you want to code along with us? Drop that in the comments below. If you want to do that, we'll provide that for you so you can kind of see what we're doing and also code along, which is going to be awesome. So let us know in the comments below if that's what you want to do.
Absolutely, man. Yeah, if you guys would like that, I can post that in right now, and you can watch us do this live. Not just on the screen, but you can actually watch us do it and interact with us.
Let's do it. Actually, let's do that, Michael. Let's do it.
Okay. It looks like they want it. Yes. Let me grab the link here. I'll post it right here.
People are like, yes, let's go.
Awesome. So that's a great way to set it up. Now I want to say one more thing. We actually have a GitHub set up. And on this GitHub, I tracked every single change that I made and how I built this app. And you can go through the entire history for those of you that know Git, and you can actually see this whole thing. So this is something where you can download the code. The previous link I sent you is how you can code along with us.
Okay, so let me go ahead and post the link where they can code along with us, okay? Where did you send it to me? Where did you send it to me?
Yeah, I actually put it in chat already. I'll put it in chat once more here.
Put it in chat. Go ahead and put the link to where they can code along with us.
Code along.
Yeah. And then the GitHub link, guys, the GitHub link to everything that well, not that chat. Give me the chat, not put in Slack chat.
Okay, perfect. I put it in the YouTube chat, and I also gave it to you there.
Sweet. Hold on. Let me see. Send to me in Slack.
Absolutely. There you are.
Yeah, but like, with the GitHub link, we will actually provide that for you guys later. Don't you guys worry. We'll provide the GitHub link for you later, so you can guys code along with us, so you guys can see what Michael did every single step of the way. That's the really cool part. So let me go ahead and provide this right there. Boom.
Yeah, awesome.
Voila.
Post that in chat.
Sweet. So you guys can see that. Let me do a few more times. Boom. All right, sweet. You guys should now see that link. It should be everywhere now, guys. But people are like, I got it. no need to spam me. Oh man, sweet.
Awesome,
sweet.
Dude. Okay, so what's cool about this is going to get you started with all the same stuff that we have. You're going to be able. This is just the white screen. So this is going to make it. We're going to bring up a white screen. What we're going to launch into now. So now you have an understanding of the basic game loop, right? So the way it works is we set up a window. We initialize Pygame. We set up a window. Then we say we monitor for events, and we're only doing two things right now. If we quit the game, we quit the window, and if we press the escape key, we quit the window, and then we make the window white, and that's all happens in the game loop.
Yeah.
So there's
so all that's going on in here, right? So escape game. So when you click escape right there, then you quit the window. And then got it. Okay, keep going.
Absolutely. So the basic way, there are three main things we need to do. We need to start the window. We need to then update. Sorry, the first thing is we need to update the logic behind the game, and this is where things get really interesting, and this is what actually makes it complicated. So that we're gonna go over this in detail.
I got an idea, Michael. As you are saying this, I got an idea. So here's what we'll do. Let's make a comment like this. So make a comment like this, so you guys can see what I'm typing, right? So as you're saying this, so actually go ahead and type up like what are the steps that we're gonna do, right? So let's do like number 1, and that's gonna be a comment. Do this. Number 2, do this. So let's go ahead and type that up so people can see, right? And that like it's visual.
Absolutely. So we need to, number 1, we need to worry about, there's a few things we're worrying about here, right? So number 1, we kind of start with the window. Oh, here we are. We start with the window. So we draw the window. We create the window.
Okay.
Now we have something to draw on. Then we say, okay, let's update the game logic. So this means, let's move our snake. Let's find a new spot for our apple. Let's check if the snake ate itself by accident.
Nice.
These are all things that happen.
Okay.
We handle input, and this kind of ties in with our update game logic, right? So if I press a button, the game logic changes a little bit, and now if I press up and it was going left before, now the snake's traveling up. Or if I move it into an apple, then finally we use the data to draw graphics.
Right.
Now this is the basic loop, and you can kind of summarize this as clear the screen. So you clear the screen. They gave me some autocomplete there. You clear the screen. You update the game.
And that's under the use data to draw graphics, right? Correct. That's under this, right? That's under that.
Yeah, we drawing the game as graphics. Update the game is like handling the input, the game logic, all that. And clearing the screen is, every time we do this, we need to clear the screen and redraw stuff.
Nice. Beautiful. Yeah. Okay. I like that. Okay. I like that division. I like that. Okay. Let's keep going.
Absolutely. So this is pretty common in game development here. And I'm going to leave these for you guys. Now, what I'm going to jump into is the meat of our topic today. We have 4 big things that we need to go over, that we're going to go over in detail so that you guys can understand how we break apart this problem. So let me do this, Naz. I believe there's a way where I can actually share a whiteboard. Let me do this. Now, is it okay if I share my screen here?
Oh, you can't. Not really.
Okay, no problem. So what I'm going to do here is we'll just do it in the code. So there's 4 big things that we want to do. We want to worry about, number 1 is think of the behavior. Number 2, constants. Constants. Number 3, we want to talk about the data definitions. And number 4, we want to go over our functions. Now, this stuff trickles down, and I think you can see here, we start with something that's really broad and undefined.
Right.
And then as we get to the final thing, functions, it's very specific, and we kind of know like exactly what we're working with.
Yeah, okay.
So this is what it looks like to kind of work in a game, or work with any program, really.
Okay.
So we're using the example of making a game here. So we want to understand how does our game work? What are the rules of our game, right? We're not making chess. We're not making tic-tac-toe. We're making Snake. These are different games with different rules, different behaviors. So first thing we need to think about is, okay, what are the behaviors of this game?
Okay. Let's think about that. I like that.
So we have behaviors here. So number 1, let's talk about, for example, let's talk about the screen. We know that when we move a snake around, if it touches a screen or if it touches the edge of a screen, the game's over. So we can talk about our game over state, right? Okay. So here's a couple of things that happen. Number 1 is the snake hits the edge of the screen.
Okay, makes sense.
Yeah. Now, another thing that might end the game here is if the snake touches itself.
Oh, right. Okay, makes sense. All right.
Yeah. So these are the 2 biggest.
If you have like a loop, basically, like it's like you're talking about like an actual loop. Okay, got it. All right.
Yeah, and right now it's not about code. It's not about how are we going to implement this. It's just essentially defining your goals for your program, and this is actually also important. Your not goals. So not goals are, and I'm sure you know this, Naz. Not goals are things that you specifically state you don't want to worry about. Because what can happen is you can start having all these ideas, and then eventually you get to a point where you never complete anything because you keep adding functions.
Yeah.
Features.
Yeah. I meant like a loop, like basically when a snake looks like a loop,
Oh yeah. I see what you're saying. Absolutely. So we have the game over state. Now, what's another thing? Well, let's talk about the movement. Movement of the snake.
Well, it looks like Grapple is loading.
What's interesting about the movement of the snake here?
Okay.
Well, when I press up, we have a flat snake. It doesn't rotate, right? What happens is the top of it starts to move up, and then the rest of the snake's body follows behind and moves up at the same time. So we can say that its body trails its head.
Hold on, where are you typing, Michael? Because I can't see you typing.
Oh, here, let me do this. Sometimes REPL does this, so I'll refresh real quick. And what we're saying about the body is that, it doesn't just rotate around an axis here. I'll paste it in just a second. It doesn't just rotate around an axis here. It follows the body, completely trails the head instead. So my thing's still loading here. Just about done. Okay, there we go. Did you get that?
No.
Okay, you might have to refresh on your side. Sometimes that happens with REPL.it.
REPL.
So now we have, and it'll load and just, there we go, perfect.
Beautiful.
So now we have a game over state. We know that happens. We know that the snake movement is interesting in the sense that the body follows the head. What else do we know about the snake? Well, when it eats an apple,
it gets bigger.
Yeah, it grows by 1.
Right.
Grows by 1. And that's one of the major mechanics of the game. Because of its interesting movement where you leave like this trail of where you've been and it snakes behind it. And also the fact that every time you eat an apple or food or whatever it is, it grows by 1. It starts to get really hard to manage because, if your snake is almost as many blocks as there are tiles in the game board, you have the whole thing filled up with snake, and it's really hard not to hit yourself. So that's one of the major mechanics of the game, is that the body trails the head, and that when it eats food, it grows by 1. Now the score is essentially how many times you've eaten an apple. Right. So we can mention that, right? We'll have a score. We'll have a score here. And the score is essentially how much food has been eaten. I've always thought of it as an apple, so I guess I coded it as an apple, but you could call it food or whatever. Now there's 2 other things here. We have a menu screen. So the menu screen here is just the entry. It shows 1 time. And again, it's not about the code. We're just talking about what's it going to look like to play this game. What does it feel like? How do we use the input?
Think of this as kind of like requirements for the game. Like you guys have to kind of draw out or write out what you want the game to look like or what the process of the game is before you start coding, right? That makes sense. And when you start coding, it's like, oh, then too much stuff is going to change. And then, so this is perfect. So let's continue on.
Absolutely. Yeah, especially this is very common in web design where they first do a wireframe of the website. And then somebody will go in Photoshop and make it look realistic. Yeah. And then once they have an understanding of, oh, this is what we're aiming for, that's when the code starts.
Yeah, exactly. Beautiful.
So we have a menu screen. It shows 1 time at the beginning specifically. At the beginning. And disappears on any key press. We have a game over screen, which displays when snake hits wall or eats itself, and will go back to a new game on any key press. Let's see here. So we have the game over. We have a snake movement. We have the snake and the fact that it grows. We have a score. We have a menu screen. And I guess the final thing would be maybe key input. We would specify that, and we would say that the arrow keys and WAS and D change snake
direction. The direction.
Yeah, snake direction.
So basically, if you press to the right, it goes to the right. If you press up, it needs to press up. It needs to go up. Okay, I see what you mean.
Yeah, absolutely.
But one thing should we mention as well is that the snake movement. Okay, you said body trails its head. Okay, makes sense. Got it.
Yes, absolutely. So this snake is a rather simple game. Now you could think, for example, of a really, really popular title, AAA game like Call of Duty. Imagine trying to list out all of these things, right? Where it's like, okay, we have all these different game modes. Each character can customize these attributes about it. We can do this to these guns. There's tags. Now there's a multiplayer networking aspect to it. This is a massive game and a massive problem. And they need to make this game run with these awesome graphics in 60 frames per second. It's quite a feat of software engineering. So imagine you have this huge problem and you think to yourself, I'm going to make this shooter and it's going to look kind of like this. And then you just dive into the code. The number one thing that's going to happen is you're going to code yourself in a corner. Oh yeah. So you're gonna have this. You can think of it it's called software architecture for a reason. You can think of it kind of like building this really brittle house where if you try to make any change, the entire house is going to fall apart.
Yeah. Yeah.
So when you take the time up front to say, okay, this is where the rooms are going to go, this is where the garage is, I want this many windows, then you can start to think about, okay, how can I do this and make it structurally sound?
Yeah.
And that's what software architecture is.
Yeah, think of it as like, what would happen if you literally think of it like, drop that in the comment below. What would happen if you try to build a house or heck, any building without having the right plans for it, the right foundation for it, or anything of that sort? Like, literally, guys, what would happen?
Right. Yeah, you just started throwing wood together, and then every single time a problem comes up, you just apply another 2x4.
or you use duct tape.
Or duct tape.
That's not gonna be a very strong building. But anyways, yeah, let's keep going.
Yeah, absolutely, man. I love that insight. So we have our behavior now. And what's nice about the reason I chose Snake is that it's a rather simple game, and it makes it easy to define the behavior. So what we're going to go from here is we need to talk about the constants now. So what we have in this game is an idea of how everything works. And I'm going to jump into this idea in a second, which is the idea that as what we really do as programmers is manipulate data. But before we get into that, this game has a lot of what are called constants. So things that never change. And we want to think about those constants, because if we don't think about those constants and we don't think about to ourselves like, okay, these things don't change, it's essentially things that you have to keep worrying about, right? So you don't define them anywhere. You have to write the numbers in manually, and these are called magic literals. So you write these in numbers manually. And then imagine if you wanted to change, let's say, the frame rate of the game, or you wanted to change how fast the snake moved. You'd have to find that in every single spot, change it, and hope you didn't mess that up.
Right.
So taking everything that's constant and putting it into one file or into one place where you can modify those things is really important, because it's gonna make your code easier to maintain and easier to change.
Yeah, perfect. So let's do that. Are we doing that right now?
Absolutely, we're doing that right now. So we're going to think, the first thing we do is think about, okay, what is constant in the game? And I have, obviously I have some understanding here. But I want you, first of all, guys, you've been hearing me real quick in chat. I want you to tell me, what are some ideas you have? What doesn't change about this game? What are some things that don't change whatsoever? And let's see if you have any ideas.
That's a good question, guys. Like, what doesn't change about the game? Let's keep going. It gives, because we have a delay of like 30 seconds, so let's keep going with that. Yeah. And then we'll see what people say.
Yeah, absolutely. So we have some constants here. So let's think, how would we think about what doesn't change here? And I'll give an easy answer while we let the comments filter in. One thing that doesn't change for sure in this specific example is the width of the window. We're working with an 800 by 600 window. It's going to stay that way the entire game. Oh, perfect. I'm starting to see some comments here. So we say, someone says the apple size and color shape doesn't change. That's true. The snake's head doesn't change. The speed. These people say the width of the snake, the size of the window.
Apple size, color. Okay, nice.
Yeah, and a lot of these are really good too. Speed, all of these things, absolutely. So. And this is awesome. This is exactly right. Most of these are exactly what we're going to be defining.
And you guys are smart. You guys are smart. I like it.
Yeah, definitely. So let's write that down. Let's see some constants here. What do we have for constants? Well, we'll just list the general idea, and then I'll write the code. We've got colors. We've got the window dimensions. We have window dimensions. What else do we have here? Let's think about this. We have, so the colors, the window dimensions. Well, there's going to be a size actually for each cell, right? Because the snake kind of moves and jumps.
Right.
So there's the size of cells in the game.
The speed.
We have
the speed as well, right?
The speed. And in this game, we're doing something called where we tie the speed of the game with the frame rate of the game. So we're actually going to refer to that as frame rate here. And that's because there's no like animations where like weight animations or like where it squiggles back and forth or anything like that.
Right.
Frame rate actually dictates how fast the game moves. So yes, the speed.
Beautiful.
Let's see, what else do we have here? We have a cell size. So, if we have a certain size for a cell, it's kind of this arbitrary number. The cell needs a width and a height, and that's in proportion to the window dimensions. So we would say cell width and cell height. Okay.
Nice. Okay.
And these are actually most of the constants. So what I'm going to do here is I'm going to create a new file, config.py. And what's going to happen in this file is we're going to create a class called config, and it's going to host all of our constants. Now, in Python, there isn't a constant keyword. And what a constant is, for those of you that don't know, is something that when you create it, it cannot be changed.
Yeah.
And the way we're going to handle that is just
the value, guys. The value can't be changed. So let's say, for example, you have a constant, but a constant like in this case, let's say we have FPS, right? Like you cannot just go in later on and choose the FPS to like be 10, right? It's always going to be the same.
Yeah, during what's called the runtime. So while the program's running, FPS won't change. Yep. But if you stop the program, change the values, and run it again, obviously that works.
Yeah.
Okay, so now I have this from the working project. I actually know that this is everything that I need. And we have a couple of certs here too because of the way we do our cells. We're essentially saying that they always have to be a multiple of 20, the width and the height. And that's why we get this 640 by 480 window. And these are our constants. We're going to use these white colors, these red colors, black colors, green colors.
What is the cell width? Can you explain this one right there? So cell width divided by cell size?
Yeah, absolutely. We're going to use that inside of the math of our game to determine how far apart to draw the lines that define the cells, as well as using that to draw these green squares that represent the snake and the apple. So this cell width is actually a pixel value that represents the actual width of the square that we're going to draw.
Okay, got it. Makes sense. Got it.
Absolutely. So we have these constants here, and we'll go into more detail. Again, I want this talk for you guys to be really about how do we think about structuring this program. In our course, we go in depth entirely on like, okay, how do you think about, we have an integer value here and like these asserts, and we get nitty gritty about Python. We really go into that, and that link's below for you guys to check out. I would highly recommend that. Do that before it gets off your brain. It's really important. But on this talk, we're going to talk about how do we think about a program, how do we structure the program, and then how do we implement that program. Awesome. So now we have a config, and inside of the main, this isn't going to do anything, but we now have access to, what's called a config. The next thing we want to do, okay, so these are our constants. We've done our constants. The next step, and this is actually my favorite step, this step actually changed how I thought about programming. We're going to talk about data definitions. So what are data definitions? Well, let me bring this up here because I want to just focus on the camera
guys,
for a second.
What do you think are the data definitions? Drop that in the comments below. What do you think are data definitions?
Yeah, absolutely. Yeah, I'm curious here. What do you guys think the point of having a data definition is?
Yeah.
What's interesting?
Yeah, let's start explaining that, so that because while they come in, it's probably gonna be 30 seconds or something.
Yeah, definitely. So I would start by saying, okay, what are we doing as programmers? What's so important here? Well, your computer uses data. Now, we're not going to get into the hardware aspects of bits and things like that, but what you're really doing is moving lots and lots of data, and then you're using that data to draw things to the screen and being able to interact with it. Whether it's just a simple console application where you draw text to a screen, and by the way, some of those can seem simple on the front, but do very complicated math in the back, or you're building a video game. What you're really doing is working with data, manipulating that data, figuring out how do I represent this data, and then, drawing it and providing that to a user in a way that they can interact with it.
Right.
So, in fact, the first computer was built. I'm sure you guys have seen that. I forget what the movie is. It's awesome. It's with Benedict Cumberbatch, and he plays Turing, and he builds a computer that breaks the Enigma, which is like the German encryption that they used during World War like 1 or 2. I forget which one.
Right.
So originally, the whole point of it was to do data and to do it in a way where you could reprogram it and change it, because that encryption would change every day. So that being said, right, okay, we work with data. We work with data. So the most important thing that we can do as programmers is think really hard about what data are we working with and how do we represent that data. So let's think about, in the context of our game here, what are we working with? What is a snake game? What makes a snake game a snake game? What objects are in there? And how do we talk about that? So while you guys are thinking about this, post in the comments here. Let's hear about it. What do you think? What makes a snake game a snake game? Right?
Like
it's
in terms of data, you're saying, right?
Yeah, exactly. Or just think about like the general thing. So like the fact that there's a board, right? We have a game board. There's a snake, there's an apple, things like this. This for the snake game, this is why I chose this example. It's actually pretty simple. So what I'm going to do is, first thing I'm going to reveal to you is the apple. So what is an apple, and how do we define that in code? How do we represent an apple or food in code? So let's think about, again, let's go back to our behavior. Again, this trickles down. So if we think about it, right, we close our eyes and we think about it. We know there's a game board, and there's all these cells, and the snake is traveling a certain direction, and there's an apple in a cell. Now, that apple doesn't move during the game, stays exactly where it's at. It can be eaten, and then it gets placed somewhere else. So it stays exactly in the same spot. Okay, so how would I represent that in my code? Well, what we have is essentially an apple is an X and a Y. That's all it is.
Coordinate. Oh, X and Y coordinate.
It's an X and Y coordinate. So if I go here and I bring up apple, and I'll just code this one with you guys because this one's really simple. We're going to make a new file. We're going to call it apple.py. And so what we're saying here is we're going to make a new data type, a thing that represents something that's in our game. And we're going to do that by creating something called a class.
Hold on. So you just created an apple. Hold on, let me make sure, because it looks like I don't see it on my side. Hold on. So you created an apple, correct?
Oh yeah, absolutely. Let's see.
So apple. Okay, I see. So apple. Okay, and you created a class. And explain why you're creating a class.
Yeah. So that's exactly what I was just talking about, where we need to define data, right? How do we represent an apple? Well, an apple is kind of this combination of two things. It's this X location and this Y location. So how do we represent that? Well, a really great way to represent this is a class. A class is like this thing that takes all these different data types. Let's say it's a person, for example. A person could be a name and their health and their relationships to other people. And this would be a great thing to define in a class. Well, an apple is a thing that has a spot on the board, and that's really it. That's all it really has.
Right.
So we would have an apple. And again, we cover all the nitty-gritty details here, like this underscore init and how this all works in Python in our course in excruciating detail.
Yeah.
But what we really want to go over here is how do we kind of define this thing. So what I'm saying here is that Apple has a function, and a function, for those of you, I'll briefly say, is a function is essentially something you can call and it does stuff for you. That's really broad, but it's the best way to think about it. So we would say that we want a function here, and I'm going to grab this from the code, that gives us a random X and a random Y. Now you'll see it's mad at me. It's all red and underlined, and that's because in Python, we import random here. And another thing we're going to need to import, and I'll talk about this in a second, is our config. So what does this do? This function, set new location, essentially sets an X and a Y coordinate for the apple. And it gives us, what it essentially does is gives us a 0. It puts it anywhere on the game board from the top left to the bottom right. So this can be a random number, X and Y, that represents, X and Y on the game board somewhere. And it's going to give us a random number for each one. And what we're going to say here is, let me fix the indenting. We're going to say that when the object is created, it sets this random location.
Nice, nice.
So every time we create an apple, it's going to look just like this. It randomly sets a location for us, and that's it. That's all we do. So this is the data of the apple, right?
Mm-hmm.
It doesn't draw anything. We can't see it on the screen yet, but what we can do is we can work with it. We can delete it, move it new places, all these things. But this allows us essentially to create new apples and move them. And this really represents the behavior of an apple, right? Because when a snake eats an apple, it doesn't move up one,
Mm-hmm.
doesn't move down one or move over three. It's not predictable. When a snake eats an apple, it moves somewhere random again.
Yeah. Somebody asked a question. Why config the cell width -1? Like, what is this? What is this for?
Yeah. Okay. So we talked about constants, right?
Mm-hmm.
So we have a width, the cell width and the cell height. This is how many cells are in the game, right? So it's going to be, let's say it's like 16 cells wide and 16 cells tall. I'm not sure exactly. I didn't count, but there are that many cells. So what we need to say is give us a number between 0, which is the start. For those of you that don't know, it's 0 based. It doesn't start at 1. It starts at 0. So 0 all the way to the end -1. And again, these are really specific details about programming. It has to do with arrays. But essentially what we're saying is give us something. You can be anywhere from the start on the left all the way to the right.
Got it.
Now this config, what this is this is a constant that we defined. So if I ever wanted to change the game board, or I wanted to change how big the cells were, any of that, I could do that because it's all set right here. I just quickly change the value, rerun the game, and the game's different.
Right, gotcha. And so I think the reason why it's also cell width -1 is because the fact that we, since in programming you guys use between 0, right, between the letter 0 and between the letter 0 and the number, right? If you say the width is 16, in terms of the actual values of address of that cell, it goes from 0 to 15, right? It goes from 0 to 15. And so if we instead of doing -1, we said just the cell width, then at some points, I'm not saying always, it might actually pick a number 16 instead of 15, which will cause us a problem, which will basically take the apple outside the board, because again, the address of those specific cells, or the apple in this case, is going to be between 0 and 15, not 16. So, yeah, so hopefully that explains that part as well.
Exactly. And for those of you where that didn't make sense, again, we go over this in excruciating detail. It's in the links in the chat. It's also in the description. Give that a click.
Check it out,
that a click. Yeah, before just do it right now before it gets off your brain. Give it a quick look, and just talk to our team. You don't have to buy anything. Just talk to our team. I'm sure they can help you.
Yeah. Perfect.
So back to our game here. We've defined our constants. And what we're doing right now is defining our data. So it's like, okay, how does this data work? So we know an apple is an X and a Y. Now let's get to something a little more complicated. What is a snake? Because a snake is kind of this weird thing, right? It has not just one, but multiple of these blocks. Each block has, like, I'm going to say it briefly and vaguely now, but some stuff going on. And we don't know how to define that in data yet. And then it changes. It changes the entire game. So it's like, okay, what do we do here? Well, let's break it down. A snake is this list of blocks, right? It's a whole bunch of blocks. And each block has an X and a Y coordinate. Okay. So we have an X and a Y coordinate for each block in the snake. And the snake, the entirety of the snake is all of these blocks. Okay, interesting. So if we were to think about this snake then.
Are you creating a new file, snake.py?
Not yet.
Okay.
Yeah, I'm just in main.py actually.
Got it. Hold on, let me make sure I'll go in there as well.
Yeah, let's make sure we're synced up for a moment here. I'm on line 44. Can you see me typing?
Yep, I can see you now.
Awesome. So we have a snake, and we could think of it like a list, right? It's a list of blocks. Well, we could also say that okay, let's use a data structure that's inside of Python that's called a dictionary, and we could give it an X value. So essentially, real quick, a data structure is something where you can say like you get the this blocks dot X and this blocks dot Y. That's kind of like a class. It's similar.
Right.
So we have an X, and it would have some kind of X value, right? This represents where it's at on the board. So let's say 1. And it would also have a Y, and this represents the height on the board. For those of you that don't know, in computer graphics, Y0 is at the top. It's actually not at the bottom, but the top. So if we did 2, it'd be 2 cells down, essentially, from the top. And this would represent 1 block. Okay, so now we could say, well, what if we started the game with 3? Let's say the snake starts 3 long, and it does, if you notice that. Where would the next X be? Let's think about that. How would we do the next X? Well, it would be probably, right, let's say this array is called snake. It'd probably be snake, the head, right, the head here, and we'll talk about that in a second. That's actually something we defined. We will define inside of our snake class. It'd be the head, which would be 0 plus 0, here we go, dot X. So this is what we're saying is it's going to be, okay, the same X coordinate as the head, but actually back 1, because it's going to be facing this way when we start the game. So what is a snake? Just to make the, again, we're getting into kind of nitty gritty details here. What is a snake? Well, a snake is really a list of blocks. That's really what a snake is. It's a list of X, Y coordinates, and each one is one of the segments of its body.
Got it.
So let's start to implement that. Let's think about, okay, this is a snake, and this is how we're going to work with our game. So we'll go to snake, and I'm quickly going to, I'm just grabbing this from my reference file. I'm going to make a snake.py. Awesome, you see that. Now, we need to import our config, because this is the object that gives us all of the constants and all of these things. And we'll make a new class called snake. So this does nothing yet. Snake is meaningless.
So okay, we're defining a class just like how we did for the Apple guys, right? It's just that this time we're going to have different attributes and different configurations for this specific class.
Exactly. Yeah. And again, this doesn't draw a snake. This doesn't make the snake. This is the data that represents the snake. And we'll take this data and use that to draw the snake later. So we have this now. Okay, fantastic. So when we create a snake, when we say, okay, let's make a new snake, how do we define these things? What is it? What direction is it facing when it starts? Where does it start? Also, do we have any, is there any snake attributes to it yet? And there is. I'm going to take this again, and we have this fancy function.
So I'm just going to expand this.
Which again uses random. So I need to import random. And so what we're saying is init, we're just saying when we create a new snake, again, I'm going over in high detail here. When we create a new snake, we're going to give it a random start X and a random start Y. These things are never used again. These are just the starting coordinates. We're going to say, okay, it's moving right. By the way, what are these guys? What do you call these? It came before data definitions.
Constants, right?
Constants.
Yeah,
yep, constants.
There we go. Somebody give me a piece of candy because I got it right.
I'll give you a crisp high five, dude.
There you go.
So, these constants, they don't pertain to the rest of the game. They only pertain to a snake. So we're going to put them inside of the snake. That's where they belong.
Yeah.
So we have these constants, and we say, okay, we have up, down, left, right. We're working with strings here. This kind of gets into like typing and things like that. We won't worry about that. But we're saying, okay, it's going to start somewhere random. And you'll notice here, it doesn't start on the edge ever. It starts 6 away from the left and 6 away from the right, or 5 away, actually. So we never start on the edge. And we're going to say, we'll just start every game. We start moving right. And this is our initial snake. This is how it starts. So you'll see that it has an X and a Y. And it gives it the start coordinates. And then it builds a few more blocks, just one behind the head and then 2 behind the head. And you see that with the -1, -2. So this is the start of our snake. This is what it looks like. And this is just the data. Again, this represents our snake. Okay. So now, what else does a snake do? Well, a snake moves, and a snake also, can potentially eat an apple, right? We can eat an apple. So I'm going to kind of, I'm going to grab something from our previous file here. And we're going to talk about, well, first of all, actually, I'm sorry, guys. Let's take a step back real quick. We're working on data definitions, right? So we said that a snake is a list of XY coordinates. So what this, this is kind of some surrounding stuff. We have some constants here that help us build this up. But where's the snake really? Where is the snake? And the snake is right here.
Right.
This is the snake. This is the data that represents the snake. This is the data that we use to draw the snake. This literally is the code that is the snake in our program.
It's kind of
just as the X and Y, just as the X and Y are the apples in our program.
Right. So like if I go to apple.y, you can see this X and Y. This represents one object, the apple. But because in snake, because you have a because in snake you have what's it called? You have a the trailing tail head, right? Like this is, think of it as like the block in front of it. This is the block behind it, right? If you think of, is that my correct understanding? Is that right? Is that how, right? Okay, good. Yeah. So basically, what I see it is like, think of this as the head, right? Then what's the thing behind the head, right? Which is the second block of the snake. That's going to be this. And that's simply going to be this number, the x coordinate minus simply 1, and that's pretty much it. And the same thing goes for the one behind that, the third block, which is going to be x minus 2. So yeah, okay, I got it. That's actually really interesting. I didn't think of it like that way. That's really cool.
Yeah, exactly. So this is our snake. Now, something I would love to do again, if people really like this, we can get back on and talk about refactoring and making things even better. But we're just going to go through with this for now.
Yeah.
So now we have an apple. We took our constants out, so our constants are handled. Then we thought about, okay, what is a game? Well, it has an apple, and it also has a snake, right? But there are some things that are in, and we're talking about data again. There are some things that make up a game that aren't just those things. So now we need to talk about, okay, we're actually working with a construct, right? A piece of data that's called the game. And the game does have an apple and a snake, but it has a few more things. So I'm going to start by saying we're going to create a new file. Let me know if you see this.
Game.py. Okay, beautiful.
So this is our game. And I'm going to start by doing a couple of imports here. And you're going to say, okay, we use the config, we use the snake, we use the apple, and now we're importing the real exciting part, Pygame. Pygame is a framework that we're using to draw graphics to the screen. That's a very complicated subject. We're going to let Pygame handle that for us.
Got it.
Okay. So now we have the imports. And again, it's as simple as saying, okay, what is a game? Well, we start with class game. We're making a game now. And we start that by saying, okay, what's in a game? What makes a game? We have a snake, we have an apple. Okay. You know what else makes a game? Is actually the screen. The screen makes a game. The clock makes a game, right? How many frames are we doing per second? Right. The fonts that we use make up the game. These are actually the real building blocks here. So we have an apple and snake, but we also have all of this supporting stuff that lets us see the game, essentially. So I'm going to put this in, and I'll quickly go over this. Pygame init starts, and this was in our original function. Pygame init starts the game. So we say, okay, we have a thing called screen now. And it's equal to, and then pygame.display.setMode. This is the screen. This is the window that we display. And again, what do we see here? Constants, the window width and the window height. These are constants. Okay.
Which we define inside the config.py file right here. So this is the window width. Where is it? Oh, right there. Wait, no, hold on. Where? Window width and then the window height. Got it? Okay, let's keep going.
Yep, absolutely. Now we have a clock. We're saying, okay, there's a clock here. And that's equal to, again, provided by Pygame that handles all this like real nitty gritty stuff for us, a new clock. And then we finally say, okay, let's have a font, and we're going to use this font free sans bold. And then this is just some setup for the window. We say, okay, give it a title bar that says Wormy. And finally, you'll see that we make an apple and a snake. They're equal to apple and snake. So we're using that now. Okay. So our game has been set up. It doesn't do anything yet, but the data is there. We now have a well-defined and articulated idea of all of the behavior of our game. We have an idea of what doesn't change about our game. And finally, of all the things that do change, of the things that we do manipulate and change, and that makes our game fun and dynamic, we have an idea of how we represent that. And now it makes it really easy to understand how we might change it in order to make those changes in our game.
Right. And just as a small explanation, guys, the init function right there, because some of you guys have asked that question, guys. The init function is basically when you initialize this class game, this is the first thing that gets run automatically, right? Think of it as like, this is my, some of you might know this word, it's called a constructor, right? If you don't know this word, that's okay. But think of it as like, this is your initialization, right? Your function initialization, where you initialize everything. Anything you want goes in here that gets initialized. So just as a small explanation there.
Absolutely, man. Awesome. I'm glad you put that in. And I want to take a quick break here and see, what do you guys think about this so far? Is this the process of thinking about behavior, taking out the constants, thinking about the data? Is this stuff that is helpful for you? Because the biggest thing, again, we hear all the time is there's if statements, for loops, while loops, but how do we make a program?
Yeah.
How do we actually do something with this? So is this something that you guys, type in chat here? What do you think about this so far?
Yeah, they're loving this. A lot of people are saying some really nice things. People are like, one guy, AJ, is like, love your teaching style, man. Love your teaching style.
Awesome. I'm glad you guys are liking it. And if you guys want to learn more about just the real specifics, like, like what is a class and what is this constructor thing? And, there's a lot of stuff we're not going over. Again, check the link. You don't have, again, just grab the link. We have a little chat thing there. Talk with somebody. They can help you. And at the very least, you're going to have an awesome conversation with somebody. Beautiful. At the very least. And they're going to point you in the right direction. Beautiful. So let's keep going here. We have our new snake. We have our data defined. Oh, can you still hear me, by the way, Nas?
Yeah, I can hear it perfectly.
Okay, fantastic.
Crystal clear.
Crystal clear. So we have our data defined. So what's the final step? How do we finish this whole thing up? Well, we do functions. We have functions. So now is the exciting part. All of our data is fine. We have a structure, an idea of how this game comes together. Now we actually do stuff. Now we actually get things to run, figure it out. It's an exciting time. We're actually going to figure this out now. So the first thing I'm going to say is, if you take a look, Nas, at our original project, not new snake, but snake, which should be open in a different, awesome. And you look at our main there, you see how simple that is? Yeah,
it's pretty simple. It's like 4 lines of code.
Exactly. And it makes sense, right? We start a game, we run the game, and when the game's not running, we quit.
Cool. I like it.
It makes sense. So that's how we've structured our data. So if we go to main here and our new snake instead, you're going to see that we have all of this stuff. Now I'm going to leave the comments for everybody so you can check it out. But what are some things we're doing here that we don't need to do anymore? Well, number one, we set up a clock and a wormy, this is the title, and a window and all these things. I'm on line 47.
I see it now. Okay, perfect. Okay.
Fantastic. So we have all of these things going on here, and we do the Pygame init. Well, that's handled in our game. We already I kind of cheated a little bit and wrote a function right away, but it initializes all these things for us. So let's get rid of that. We no longer need that. Now we have, it's erroring because these things don't exist, and this is called refactoring. But now let's do this instead, right? Let's create a game loop, and let's use this code. We're going to have the same functionality, but we're going to put this inside of the game and make our main look just as clean as our other one did.
Got it. So we're gonna copy all of this while the true and put inside the game.py, correct?
Yeah, exactly. So I go to game, and now we're going to be working with functions, and we have you would need some understanding of Pygame and things like that. But we understand, okay, this is how Pygame works. So we're going to make a run function. And we're just going to literally put this stuff in here. I'm going to fix the indentation. And what we should get is, and let me fix this up. I need to import something called sys. Fantastic. Now the final thing here is at the bottom we have a fill, a clock, and an update. So I come into our run, and while true, we do these things. Now you're going to see, okay, it's all read at us. Why is that? Well, display surf is actually now our screen that we made when we created this object. This works just fine. Our clock is now our clock object. And let's see, we have a screen. Fantastic. And the one thing I forgot, that's a little syntax error there. Okay, awesome. So now we go into our main, and we can get rid of all of this. We can get rid of all this. This is now handled in our game object.
Sweet. Nice.
We'll make a main.
Okay.
We say our game is equal to a new game. We say game.run. We're going to quit when everything's done. This is also known as sys.exit. So we'll just say that. And I will delete a little bit of the import statements up here to clean things up.
And so when you basically initialize a game, okay, I see it now. Oh, we have so many games now. Hold on. So we have basically when we initialize this game, right? It's gonna call this init.py function, which is going to initialize all the things you need for the game. And then it looks like Michael right here. You see, he's running the game.run, which is going to start running the game, which is going to call this function, and that's going to be your main game. So we can see how we've kind of like took all this code that was inside the main.py function, divided into different parts, and now it's kind of divided up. It's nice and clean, and it makes sense. That's the most important part, which makes it easier for you to later on actually go about and run it, right? Basically, run it and actually create it.
And you mentioned on something that's really important, and I'll keep it brief for that. And what you mentioned on there was that when you come back, right? When you come back, and that's actually really important because people, if you're writing code that's important, people will come back.
Yeah.
And so it's important that the code is easy to maintain, that it makes sense, and it's easy to make changes. And that's why we split things up into objects and think about how we structure our program. It's just like a house. Again, we think about the blueprint and then we build the house. So now if I run this project, what you're going to see is exactly the same thing we had before. The only difference is that it's a little bit smaller because we've changed our essentially how this we changed the size of the screen with our config, right? With our constants. And again, we can just stop it just by pressing escape, yada yada. Okay. So now let's start to
all
do
you did
some
there was
stuff.
just simply start the game, and that was just a white screen. Okay, I see it. Got it. So okay.
Yeah. Exactly. Okay. So now how do we go from here? Well, the first thing we want to do is, and what I like to do is I actually like to save the graphics for last. And the way I would usually do this is by using what's called tests. We don't have time to go into tests today, but tests are a way that you can verify that your code works the way you think it works. So I'm going to have to do a little bit of graphics and code at the same time, but I want you to pay attention here. One thing I do that's very important is that my code that updates my game and changes the data in my game is separate from the code that changes the graphics. I change the data in my game, and then it takes that data and renders the graphics to the screen. They're not tied together. They're in fact separate, and this is really important.
Got it. Makes sense. Okay.
So this makes it easy to add functionality, all of these things, because they're separate. So what's the first thing we can do here? Let me take a look. So let's start by drawing ourselves the start screen.
Okay.
The start screen. So what I'm going to do here is cheat just a little bit. I'm going to take our game loop here. So this is what our run looks like now. So I'm going to take this and put it here. And now you can see it looks a little bit different, and we're actually making some function calls here. So let's go over that. So I'm just fixing the indenting real quick here. Okay, so what's new about this game loop? Well, let's change this back to run. We've run, okay, so it's the same, quit. Well, now we see, okay, when we press a key, instead of handling it right here, we call a function that handles the key events. So this makes it really easy, right? Because instead of reading all this super long code, we say, okay, if they press a key, then we have a function that handles the key events. Obviously, that makes sense.
Right.
We're going to comment this part out. This is our snake update function. And then we have a draw function. Okay, and I'm also going to comment out our game over code. So what's our draw function? Well, let's make it. Let's make it. Our draw function should draw something to the screen. Well, what do we know happens every single time when we draw to the screen? Number one, we want to draw this background color. So we don't want it to be white anymore. We actually want to fill the screen with a constant that we define to be the background color.
Right, okay.
We also know that at the end of drawing all of our objects, we also want to update the game. So we want to update all of the so this update call essentially updates all of the graphics and things like that.
So
and
basically, so basically what happens is that you set the data for this Pi game display, but then you're saying, okay, since I've set the data for you, now update that data, correct? Is that my correct understanding?
Pretty close. This fills in the background color of the screen, so it just does that. And then in here, we'll draw our snake, grid, apple, and score.
Got it. That makes sense.
Yeah, exactly. So all of these things will happen here. Okay. So now, but right now, if we take a look, we just draw. Okay, so we have a draw function, and it's actually going to look very similar to what we had before, except the background color is going to be different. So let's give this a run real quick.
Hold on. I'm excited to see this.
And I think its background color is actually black. So.
Is it black?
Yeah, it is.
Oh, so we can make this.
Yeah.
There we go.
And finally, we need to implement our handle keys, right? Because we need to be able to make sure that if they give us a up or a down or anything like that, we can exit the game. So I'm going to go here real quick, and I have a handle keys function. Let me find it here. And all it's going to do, right, is it takes, if you take a look here, it takes the event, and the handle key takes that event and says, okay, awesome. Now I can check and see, you know, what am I supposed to do here? What am I supposed to do here? It's that simple. So we're going to make, there's a whole lot more to this that we'll implement in a second. But for now, we're just going to do the basics. And we're going to say that if we press escape, we can quit the game.
Okay.
So again, it's a black screen, but if I press escape, then everything should quit here. Let's see here.
Do we get an
screen fill, display, surface quit. And that's actually proper. Because that's how it errors. When you call sys.exit, it does those things, but that's okay. That's what we want to happen.
Good.
So we quit the game. All is well. Fantastic. What's the next thing we're going to do? Well, let's draw the grid, right? Let's get a grid on the screen. We can start to see what it's going to look like here. How are we going to do that? Well,
is that inside? Let me just guess. Is that inside the init function? Do we draw the grid or no? Or is that inside like a while loop?
Our data for our grid exists. It's a combination between our game and our constants. So we just need a function that's going to draw lines based off that data. So actually, all we need to do is put a function call, and we'll call it draw grid, in our draw function.
Okay, cool.
Now I want you guys to pay attention to something that's really powerful that's happened here. It's really sneaky. It's hard to see, especially if you haven't been programming a lot and you haven't dealt with this frustration. What we have set up here is essentially code that is really, really easy to improve upon. We have two main things we do, right? We have our game loop, everything's set up. So let me go ahead and fix up this, and I'll add in. So I added the snake update and the game over. So this, again, this is our game loop. This is handling our key events. This is updating the snake, drawing everything. That's the grid. That's everything, essentially. And then we check if the game's over. Now, there is one final thing below this where we will display the game over. This actually goes in the game loop. But what we've done is we've set up the architecture here so it becomes so easy to add features. And I want to explain how easy it is. Check this out, guys. So I'm going to add a function. I'm not going to go over exactly how it works because it's really simple. This is our function that draws the grid. That's all it does. It doesn't create any new data. It just draws more things to the screen. So I'm going to go here.
Okay, I see
You
what
see
you're
me there?
Yeah.
Okay, fantastic. Okay, awesome. I'm going to fix up this indentation because I just have a mismatch with the indentation here.
I think you need to put one more left align, no?
For
Definition, the function.
Def.
Yeah.
Yes, I do. Thank you.
Yeah.
Fantastic. Okay.
There you go.
Python, for those of you that don't know, is really white space, and white space is important. So if you mess those things up, it can become problematic.
Yeah.
Okay. So what are we doing here? Well, we have an X in a range. It's between 0 and the width, and we jump cell size. Okay. What does that all mean? We start at 0. We're going to the end of the screen, and we're jumping in increments of 20, essentially. So every 20 pixels, we're going to draw a line straight down. And then the Y does the same thing. We start at the top, we jump 20 pixels down for the entire screen, and we draw a line horizontally.
I see. Okay.
Yeah.
And
Very simple.
And guys, and the cell size, just to get back to that, the cell size right here, right? That comes from where? That comes from the config where we got the cell size, right? We literally got, okay, here, obviously if you want to get equal width of like lines, what do? I mean, basic math, right? Let's say it's 20, right? 20, right? That's 20. And then let's say you want how many do we want cells? Let's say we want 10 cells or 10 vertical lines, right? 20 divided by 10, right? Divided by 10, that gives you, well, that's actually just 2. But that gives you just simply 2 cells. But if let's say the cell width is 2, you do 20 divided by 2, that gives you 10 cell widths, and then that way you know the cell width right here. And that's how we know that. But yeah, anyways.
Exactly. So we have all the data available to us. Everything's set up. We're ready to rock and roll. So how do I make this? How do I draw this? It is so simple. It's incredible how simple it is. This function draws the grid, right? Yeah. Well, I wish we had a function that drew everything we need in our game. As a matter of fact, we do.
I wish as well.
Here we go. Draw a grid. Now I need to preface this with self.
Okay.
And if I run this, what are we going to see? Let's see here. Snake object. Oh, and that's because I uncommented this. So this, I got a little too excited in the future here.
Wait. Oh, is game over? Okay.
Yeah, I'm just commenting out our update function. So we're just drawing the grid right now.
Okay.
And what we're going to see here is, matter of fact, a grid. Now, this is hard to see. This has something to do with REPL and the background here in REPL. Unfortunately, it's a little bit difficult to share my code here. But this displays in a window, and we get this grid. So this is the start of our grid. We have our grid now.
Yeah.
And now
look at
we need to start thinking
I don't know if you guys might not be able to see this, but it's right here. You guys should be able to see right there. I'm gonna highlight right there. You guys see that right there? Yeah, and you guys can see the lines right there as well. That is pretty dang cool. Like, how cool is that? Like, drop that in the comment below. You just drew a grid with Python. That, my friends, is pretty epic. So yeah, drop in the comments below. Give us some hype out here, because we're doing some cool stuff. Michael's doing some cool stuff out here and is teaching you amazing knowledge. All right.
Now, here's what's really cool, guys. I think you're really going to enjoy this, because what you're going to see happen is, up until now, right, it's like, oh my God, all this time and all we have is a grid. It can kind of feel like that, but things are going to pick up really, really fast. And you're going to see, because of how we structured our code, it kind of takes a little bit to get started, but once we get started, everything has been set up so easy for us. It feels like plug and play. It's really easy.
I love it.
So, okay. So we have here now a grid. And by the way, for you guys, this is one of the examples of how easy it is, right? This is kind of hard to see. Well, we have a white color, and we know exactly how to get to that. That's a constant we defined. Run this again.
What did you just change? Oh, you changed this. You changed the config.white, correct?
That's it.
Config
That's
this.
it.
Nice. Yeah. Oh, look at
now
that.
We have a white grid.
Oh, that is fancy, man. All right, I like it.
Absolutely, man. Now, again, we're having some weird issues here with the windows, and this is due to REPL.it. But this would display in a window normally. Okay, fantastic. So we have this going. Everything's going well. Fantastic. And we can quit out of this just by pressing escape. All is well. So now let me undo that and change it back to dark gray so that you guys can, when we end up, you're going to have the same code that we did. Now what do we do? Well, I wanted to draw a grid because, you know, I wanted something exciting for you guys. You know, we're getting somewhere. We're going to take a step back one more time and think about this data and how to write the functions for it. And then it's as simple as drawing them to the screen.
Beautiful.
So what is a snake? We're going to jump into the snake file. And we need to think about how does the snake, because we need to update the snake every single time, right?
Right.
So we're going to think about, okay, how does the snake update? How does the snake update? Well, what the snake does, and this is how we're going to move our snake, right? First of all, we defined our data really well. Our snake is a bunch of blocks. So how could we move our snake and get that behavior that we're getting where when it turns right, it doesn't rotate, but instead it kind of trails its body?
Right.
Well, if we have a bunch of blocks, we could move the snake by deleting the block on the back and then adding a new block on front, right? So it'd be like this essentially. So it like starts like this, and you just kind of hopscotch away. Okay, that makes sense.
Okay.
Now, what if I turn a corner? Well, we know we would need to put a block above. So let's say it's going left. I think this is left for you guys. It might be right for you. I'm not sure. So let's say we're going this direction, and then we want to go up. So instead of putting a block here, we would put a block here and delete a block here.
So y plus 1, basically. So y plus 1 would go like the next step would be y plus 1. Got it? Okay.
Exactly.
Okay.
So okay. Well, if you think about it like that, and now you're going up, right? You would take a block here, add a block here, take a block here, add a block here. Well, that solves our problem right there. That is the trailing behavior. So if we have this line of 20 blocks, that's this really long snake, and we go down one, it's going to go down one and take a block off the very end, essentially, and put it there. Then takes a block off the very end and puts it there. You can see how that is how, instead of rotating this line, we get the trailing behavior. And this was easy to do because I thought about the data. How do we represent our data? Okay, and I thought about...
Hold on. Sorry to cut you off. But okay, I got it now. So basically what you're doing is you take it from the back, you put the front, instead of trying to take the front and turn it.
Yes, exactly. There's no lines or rotations.
Okay, hold on. Actually, we can draw this up. Check this out. Hold on. This is interesting. Okay, so check this out, guys. I think this is really interesting just in terms of visually. So I'm gonna put this up on the screen. So like if you think about the snake, right, and you think about like this is part 1, right, and you think these are all blocks. You guys can see. Oh, actually, hold on. You guys can see what I see right there. These are all blocks right there. Boom, boom. Think of it. This is a snake. Okay. Now, what happens when you want to turn it? So let me do one more. Yeah. So these are all blocks, right? These are all just, X, Y coordinate blocks. What happens if you want to turn it? Let's say you want to take this snake and turn it down, right? Let's say we want to turn it down. Well, what we can do is that, and just make sure that I'm explaining this right. Because think of it, I'm just a student here, right? Just kind of trying to understand kind of what's going on here, right? What's going to happen is like this block is actually the block on the end is going to be taken. Let me point from here. The block on this end is going to be taken and put down to here.
Yep.
Right? So if I now do this, for example, right? It's going to go down to here, which is going to bring it over here, right? Then the next block is going to go down from here and going to go up to there.
Yep.
Right? Which is going to go like that. Right? And then keeps going and going and going. This is it.
Yeah. And so this can seem kind of complicated, right? It's like, okay, how do we do this in the code? Yeah. Well, let's look at our data. How do we do our data? It's a list of blocks. So all we need to do, it's actually really simple. We delete the last block and append a new block to the very front of it that is in the direction we want to go, whether it's forward, up, down, left, or right. So we take a look here. And I'm going to grab the update function snake from our game and put it in so you guys can take a look. And we're going to go over the function briefly here and then move on to the rest of the game. We have, can you see me in our snake file?
I can.
Okay, awesome. Here we are. Okay, so what's going on here? So let's take a look at this here first. So we say, we say this is the direction. It checks the direction, right? It has a direction, and if it's going up, this is where we make a new head. And the new head is an X and Y, and it's either, if we're going up, right, again, Y gets smaller as you go up, so we do Y minus 1. If we're going down, we do Y plus 1. If we're going left, it's X minus 1. And if we're going right, it's X plus 1. Then we insert, so this puts it at the right spot, a new head. So this adds the new head. Okay, so what's happening here at the beginning? Well, there are some. Sorry, my REPL is refreshing. One moment.
That's fine.
Okay, so there are some cases where, what if we're growing? What do we do there? So what we're saying is we have a check here, and we say if the X and Y coordinates, not of the body but of the head of our snake is equal to the apple. So apple, if the X is equal to apple X and the Y is equal to apple Y, that means we found an apple. So normally, you know how normally what we're doing is we're deleting the last block. That's how we move, which is handled here.
Right.
Well, instead of deleting, we don't want to delete. We actually want to add a new block so it grows one. So we don't delete, and we set apple to a new location.
Got it. Okay, makes sense.
So because snake and apple have this relationship, when I call snake.update, it actually takes an apple.
I see. Interesting. Okay. Well, looks like my code is refreshing as well. And I'm gonna paste in, guys. For those of you who are asking, I'm gonna paste in the code right now, so you guys can go along with us. I'm gonna paste it a few times so you guys can see it. But yeah. So let me.
Oh yeah, that REPL link, definitely do. It's actually just the @MichaelEslick new snake. Just without the hashtag there, and that will, if you just copy and paste that in, that they can use that to follow along with us.
Beautiful. So I just pasted it in. Beautiful. Awesome.
Okay, so now again, if I come back to the game, so our snake is done. Actually, the entirety of our snake is done. It's not being drawn yet, but it does exist.
Okay.
So now we need to check, is the game over? And this one's really easy too. We're gonna go into our config. And we're going to, let's see, or not our config, my bad. We're going to create a function called isGameOver.
Inside game.py, right?
What's that?
Inside that game.py?
Yes, exactly. Okay. So this function exists right here. I just put it in. And what does this do? Well, this function, now this is a big if statement. And again, I'd love some other time we can go over refactoring and making code really clean and easy to read and run more efficiently. But what do we check? Well, we're just checking, first of all, this is saying, did we go past the game board? So this is checking if the X and Y coordinates are less than the width or greater than the maximum width. And then same with the Y. Did it go over the top, -1, or did it go past the bottom? Then we call something called reset game, which we'll talk about in a second. Otherwise, did the snake hit itself? And that's another thing here. So did the snake hit itself? So those are our two conditions. This is a big if state. So
this if basically checks if the snake that head, right, is if basically if you think about the front of the snake is outside of the actual coordinate, so it has a -1 coordinate, right? So that's part one. Or the say equals basically the right side, or I think this right. Wait, no, shoot, wait, no.
Essentially, we just check the X and Y of the snake head, and we make sure it's not outside of the screen.
Got it. Through here. Got it. Makes sense.
Yes.
Okay.
And then I have a little helper function called reset game. What does it do? It actually deletes the snake in the apple, makes a new snake in apple, and returns true every time.
Cool.
Okay, so this is all it does. Now we have a snake. And it's been updated. So what I want you guys to see here, something interesting is going to happen. You're not going to see a snake, but the game will end. So I'm going to press play here.
Let's see it.
And it's loading. It's getting everything started.
All right, cool. I'm excited.
Starting X, still working. Here's our awesome. Now we're getting a screen finally. So what you're going to see is see how it went black?
Yeah.
Why did it do that? Do you guys have any ideas why it did that?
Drop that in the comment below, guys. Why do you think it did that? Actually, let me take a guess. Hold on.
Yeah.
Drop that in the comment below. It's a good question.
It's a little sneaky. It has to do with the way that we approached the code.
So you're saying that it ended right away.
Well, actually, not right away. It ended. It took a little bit, but it did end.
Well, is it because we need to define where the snake starts? Because when the snake starts, it is outside the bounding box right away.
I'll give you one more hint. It's not a bug. It's actually good behavior.
Huh.
So let me see if there's any guesses here.
If self.that is game over. Hold on. So hold on. If self.that is game over.
Okay. The game over, the snake went right. Yes, actually someone got it. Know it with Radhe. I don't know. I'm sure I butchered that.
Okay.
But we designed the data of our game first, right?
Mm-hmm.
So what we have here is an actual functioning data representation of our snake. So this snake is moving right now. It starts moving right. That's the initial state. That's how we coded it.
Mm-hmm.
It starts by moving right. So while we're not drawing the snake to the screen, the data that represents the snake is moving right and went off screen.
I see. So it went off the screen right away. Got it.
Yeah.
Okay.
Exactly.
Interesting.
And so what we can see is, oh, our game is actually working. This is really cool. Now, it would be more tantalizing if we had some graphics, and we're going to get that real soon here. But our game is working.
Mm-hmm.
So one thing I'm going to add now that we're missing is I'm going to our handle key button. Actually, you know what? We'll do that in a second. No problem. We have a snake. We have an is game over. What would be cool to add? Well, why don't we let's draw the snake. I want to be able to see the snake.
Right.
I think most people want to be able to see the snake.
See the snake. See the snake.
Starts chanting. So let's find.
Drop us some fire if you guys want to see the snake. There we go.
Okay, man, we're gonna see the snake. So let's go to the draw. We have a draw grid, and underneath draw grid on line 24.
Hold on, make sure that I'm following you. Hold on.
Absolutely.
Okay, I see.
Fantastic. This is our draw worm function.
Mm-hmm.
Again, what you're gonna notice here is that there's no logic in it. It doesn't do any logic. All it does is take what it needs to take and draw graphics based off that. Okay, so how does it work? We have an X and a Y coordinate. So what these X and Y really represent is the pixels where we want to draw, right?
Mm-hmm.
The starting of it.
Mm-hmm.
I'm gonna try not and go too much detail, but I kind of can't help it. I like to nerd over this stuff.
Yeah, there you go.
So we have the X and the Y, and we have a cell size, right, which is 20. So we're gonna say, okay, if the X is at 2, it's not at the second pixel, it's at the start of the second cell, which would be 2 times 20, so 40 pixels over, because we're working with pixels here.
Got it.
And the same with the Y. So, okay, this is the X and Y coordinates, and then it's offset by the cell size. Then we have a segment. So this is a rectangle. And by the way, this is in a for loop, if you guys didn't notice that. It's for every coordinate in the snake and the coordinates, right? So this does it for every block. So we get the X and Y. We make a rectangle, so using pygame.rect. So we make a rectangle starting at X and Y, and of what size? Well, our constant, cell size.
Mm-hmm, mm-hmm.
Okay, then we draw the rectangle. So we draw the rectangle onto the screen. We're going to say it's dark green. And what do we draw? We have to specify the worm segment rectangle.
I see. So it's like, so check this out. So like what I'm drawing right now, so I'm saying X plus 20 and then comma Y plus 20, right?
Exactly.
Right there.
Exactly.
So like, if you guys can see,
we specify the top left corner, and then we specify the width and the height.
Exactly. So if you specify the X and Y coordinate, right, that's your beginning coordinate, right? That's your top left, right? And then you guys can literally, and then that's what we say the cell size and the cell config, because if you do plus 20 Y 20, that brings it down to here, which is basically makes a rectangle right away, right? Nice, interesting. Okay, I like that.
Absolutely, and that's just how Pygame works.
Got it.
So then we draw the rectangle. We specify what we're drawing on the screen, the color. And then, what we're drawing. Okay. Then, and this is just a graphics thing. This isn't a functional thing. Again, these are all graphics. We have this inner segment. And what it is it's a smaller inner a smaller inner rectangle that's being drawn. So you can see it's offset by 4 in both directions. So there's 4 pixels around the side. And then this is math here. You have to do 8 actually because it's 4 on each side, blah, blah, blah. But it just draws a brighter green circle. And this just makes the snake a little more visually appealing.
Got it.
But this is what it does. This is our draw worm function. We have our data. We have our constants. We know how everything works. How do we draw this? How do we draw this? You guys have any guesses? How do
Drop
I
in the comment below. How do we draw it, guys? I'm sure you guys know. I'm sure you guys know how to draw it. Well, I mean, can I take a guess?
Yeah, absolutely.
We call it a function.
We call the function. You're right. Now, where would we call the function? You know, if only we had a function that was in charge of drawing the game. Interesting. Can you guys see how it almost becomes plug and play here? We draw worm. And what we're going to see, guys, is we're going to get a worm. It's going to be wild. We're going to have no control over it. But there it is. And there it went.
Where'd it go? Wait.
I'll run it again. Because the game over, right?
Oh, okay. Nice. Is okay. So hold on. We have the worm. Where's the apple, though?
No apple yet, right?
Okay.
No apple yet. Okay, interesting. Let's draw an apple. And we'll do this one. You know, this one's really simple. Apple's the simplest object we have in the game. I'm going to draw this with you. I'm going to work on this with you guys so that we can do it. Okay. So we need to draw the apple, right? And it needs to have a location. So we're drawing a rectangle. So number 1, we need X and Y start coordinates. So this is going to follow a very simple thing here. We have an apple and it has an X. And we need to get the coordinates, right? So X can be up to, it's, you know, the width divided by cell size. So that might be 24, let's say. But obviously we don't want an apple drawn on the 24th pixel. We want it drawn on its X coordinate times the width of each cell, right? Because we start at 0, and then we go 20, 40, 60, 80, same with Y. Yeah. So we multiply by .config.cell size. And we're going to do the same for Y. There's no difference there. Okay, so we have our X and Y coordinates. Now they're green because I haven't used them yet. And this is called linting. But we don't need to, you know, we won't worry about that yet.
Now, before we draw, guys, from what you've seen in terms of draw worm, drop in the comments below, what do you think it's going to take to draw an apple? Like, what function do you guys think we'll use to draw an apple? I mean, you've seen this, right? You've seen this with draw worm. Now, I want to test you. Drop in the comment, what are we going to use for the draw apple? We're going to give you 5 seconds. 5, 4, 3, 2, 1. Let's go.
Perfect. And just a little hint for you, too, if you can squeeze it in there. Think about the behavior here. What does an apple look like? Well, an apple in our game, if you remember what it looks like, is a red square. That's a behavior question. And that trickles down, right? That, as you can see, it trickles down to our function. Because now it's like, okay, well, I don't know. How do I draw an apple? Like, is it going to be a cool shaped apple? Is it going to be a red square? What is it? So you can see how this all trickles down. So now, okay, we're drawing a red square. Well, have we drawn a square before?
I think so.
I think we have.
I think so. The one right here. Yeah.
Absolutely. Yes, we have. We have drawn a square.
So hold on. Can I actually try it?
Yeah, absolutely. Go for it, man.
All right, so let's try it. Hold on. I want to go with you. So we're gonna say this is gonna be okay. So apple segment.
Sure.
Apple segment equals pi game.
This might be better. This is nitpicky. This might be better as rect because this is a worm segment rectangle.
Apple segment rect. Okay.
Or just rect.
Okay. Apple rect. Yep. That's fine. Okay. And then we say pi game dot rect. Right. Rect. And then we pass in, right? What we pass in? We pass in the beginning coordinate, which is that top left coordinate, which is self.apple.x. Apple.x, right?
Close to it. That would be just 0 through 20 or something like that.
Okay, so
but we need to offset by the cell size.
Okay, right. So, but okay. So hold on. So we have the beginning section, which is the top left corner, right? And we're drawing the
Uh-huh.
rectangle, right?
Uh-huh.
So, oh, I see. Okay, okay, I see. So then self. Okay, so I see it now. So self that makes sense. So self. It's just simply gonna be x,
Yeah,
comma
exactly.
y,
Uh-huh.
comma self size. So I'm guessing that this right here is simply basically the amount of cell sizes you want to shift to the. Oh,
Yeah,
okay.
it's the width. It's the
The
actual width. We have a
width.
start
Okay.
point and a width and a height.
So config dot cell size.
Uh-huh.
Config dot cell size again.
Yeah, it's a
The same.
square.
Okay, it's a square. All right. So
Ah.
interesting. So if we save that, that's pretty much it, right?
Well, we have the rectangle. Now, this is just implementation specifics of Pygame.
Mm-hmm.
So we have the rectangle, but what we actually haven't done is drawn the rectangle.
Right. Okay. So that's where we have to go. Like, okay, that's where we have to pygame.draw. Okay, I got this. Again, I got this. Hold on.
Yeah.
Got this. So we say pygame dot draw dot rect, right?
Mm-hmm.
And we specify. So obviously you have to give it a screen, the screen that you want to draw on. So self
Yep.
dot screen,
Uh-huh.
right? Self dot screen, comma. Obviously, I'm guessing in the color, right? So the color is gonna be red this time. So config dot. What was it?
And if you do control space, it might do the autocomplete for you.
Will it? Okay, let's see. Where was it? Hold on. Damn it. It went back. Hold on.
Game on line 42.
Okay,
Control
so config
space.
dot control space. Will it? Oh, wow. Okay, it does. Config dot. What is it?
And for us, it would be, well, actually, it's really easy. It's red, all caps.
Oh, okay. Just red. Okay. I like that. Okay. Red. And then the actual rectangle, which is going to be apple rect. Like that. Nice. Okay. I love it. Okay. Is that pretty much it at this point?
That's it, man. We made our apple rectangle. We drew it to the screen. But now there's missing one thing. And the only thing it's missing is that nobody's calling this function.
True.
So where do we put that?
Drop in the comment below. You guys should know this. Come on. You guys should know this by now.
Come on.
Come on. Drop in the comment below. What are you even doing out here? What are you even doing out here? But yeah, I'm sure we're going to give you 5 seconds, guys. 5, 4, 3, 2, 1. Where do we put that in?
And the answer is the draw function.
The draw function.
We draw apple. Okay, let's try. Give it a run here. There's the apple.
Dang.
And the game ends.
Wait. Why do the game ends? Why do the game just end?
Because it remember, we can't turn it yet.
Oh, yeah.
And it goes to,
okay.
yeah.
Okay. Makes sense.
So now let's think about this, right? We want to be able to change it, right? That was part of our behavior. It's a very fundamental behavior of our game.
Okay.
So let's think about our data again. How is our data structured? How does this work? Well, our snake has a direction. So and we have a function that handles all of our keys. 53 to 55 is the lines. So, okay, how do we do this? Well, I'll show you how we do it. This is how we do it. What is it? Well, it's very simple. Is the key equal to left and then this is A, D, W, S. So is it equal to left, right, up, or down? What do? We set the snake's direction equal to left, right, up, or down. And now here's what's cool, guys. I want you to see this. This is really neat. I'm going to run the game. And right off the bat, it's because I wasn't typing in the right spot.
Oh, look at that, guys. Whoa, that's cool.
Now, here's what's really cool. You remember how things kind of started working even when there wasn't graphics and things like that? Like, for example, I would run the game and the game quit, and that was actually a good thing. It should have, because the snake went off screen.
Yeah.
Well, do you guys think that this apple is going to work or no?
Okay, hold on. Let me see. Hold on. No.
Well, in fact, it does.
Oh, dang.
And why is that? Because we took so much time thinking about how our data works.
Right.
Now, where does this happen? And I'm going to let it go off screen and the game ends.
Nice.
where does this happen? We go to snake and we check our update function, lines 21 to 24 inside of our snake.py.
I see.
Well, we're either doing two things every single time we update. We either delete one of the blocks because that's how we move, or when it gets a new apple, we instead just add a new apple location.
I see.
So
that
this
adds
changes the
that
location of
adds
the
one
apple
up instead. That adds one up instead. Okay, got it.
because we don't delete one. Instead, we're only appending one, and it grows it by one.
Yeah, I see. Interesting. And you see, guys, the whole self the up, right? That's why, because that's why, the whole thing of like when you click, that's how the whole configuration of when you click up, click down, and click left and right, right? You set the snake direction to snake.up, because inside the snake.py, what do? We check that, right? Right? We check this, what's the direction, and based on that, that's where we change the coordinates. Interesting. I like that.
Okay, awesome. So now we have this working. We actually grow. What do we have left here? Well, there's actually one more display function. Let's do that real quick, and it's the score. And what's really nice about the score is that it's really simple to work with. It's very simple data. All we're doing, the score, right, is actually the length of our snake. -3 because we start with 3 blocks. So the score is our length of our snake. Okay. And then, and this is just Pygame specific behavior. Let me find the function so I can demonstrate it to you guys. Draw score. Here we are. Again, this is just Python or Pygame specific behavior. So I wouldn't expect, and I'm just now in the game, Nas, I'm going to be on line, let me find it here, 42, right underneath draw apple.
I see it. Okay, cool.
Awesome. So what does this do? Well, it simply takes the length of the worm and subtracts 3, and then this is all the drawing stuff. Now, I said this 1,000 times, and I didn't follow this rule. Do you guys know what I did wrong here? I don't expect you to, so I'm just going to go for it. I put data specific. I'm calculating the score inside of a draw function. This is bad. This is bad.
Oh, that's a lot. That's a lot of calculations, right?
Well, and maybe not performance-wise, but it's bad from an architecture standpoint, because this draw function should do one thing and one thing only. It should draw. So instead, I'm going to say that this draw score takes a score. And when I call it self.draw score,
which is where?
Inside of the draw function.
Okay.
Is it updating for you or no?
Got it. Yeah, I see it now.
Okay, good. So now the draw score function just takes a score, and that's all it has to do. And now if I want to change the way my score is calculated or things like that, I do that elsewhere.
Right.
Awesome. So now let's run the game again. And what we're going to see is that we have a score in the top right.
Oh, nice. Okay. I love that. Hold on. Give it applause. Yeah.
Yeah, man. And this is it. So as you can see, our game is getting much closer. I must have ran into myself there.
Yeah.
So let's see. What do we have left?
The end game.
Well,
right? The end game.
Yeah,
right?
we need to be able to continue to play this game. And we also need to be able to, we want a start screen.
Okay.
So let's think about this. We kind of have two things, right? We have a start screen that starts up the game, and that's done one time. And then until they press the escape key or click on the X on the window, we're going to continually start a game and do that game until game over. And then when a game over happens, we just press a button and we want it to go back, right?
Got it.
So this is what we could call our game loop. So I'm going to change the name of run to game loop.
Okay.
Now, what I'm going to introduce is I'm going to redefine run. So here's run again. But how is this going to work? Well, for now, I'll just say while true, game loop. Now, why do I do this? Well, because when the game is over, it breaks, right? And this game loop ends. So we say self.gameloop. Okay, here it is. So when this ends, what's the next thing we should do is draw the game over screen.
Oh, because it breaks out of it. Oh, okay. See, because so when this breaks, because it's a game over, that's gonna trigger the game over screen. Makes sense. Got it.
Exactly. So once the game is essentially done, we would then display game over. So this happens right here. So now, okay, we just need a simple screen that prints game over on it. And again, these are kind of Pygame specific details, things we go over in depth, guys, in our course. I mean, I can't recommend enough how important it is to surround yourself with the right people, how important it is to make sure you have somebody to guide you. What's really cool about this course is that it's such a small investment for how much you're going to get back from that.
Yeah.
We're going to talk in depth about the specifics of Python, the specifics of what's a list, what's a tuple. You guys are going to build, I think you guys even go over like some web scraping stuff. You guys talk about automation in Python.
Right
you
here,
guys talk about some basics of data science. I mean, it's incredible. You guys, they're adding new content all the time.
Yeah.
Jacob is an absolutely fantastic instructor.
Yeah.
And you guys are going to get personal feedback. And I mean, if you really want, we can talk too. It's absolutely awesome. At the very least there, Naz, do we see, I believe there's a little, do you have the ability to chat there?
I do.
Or is that just on your screen?
What?
That's awesome there. Okay. Okay. Awesome. No, my bad.
Yeah.
I misread that.
Yeah.
But what we go over, as you can see there, we have the live Python training calls. You're going to get stuff like this every single week recurring.
Mm-hmm.
You're going to get exclusive access to our community. It's awesome. Definitely check it out.
So guys, if you just watch this, and even if you like just a little bit, like, I mean, I know you guys loved what we just provided for you because this was just a lot of value. Michael did an amazing job explaining this. Like, seriously, an awesome job for that. The guys, this is just the cusp of it, okay? If you're interested at all at becoming a Python developer, making a killing as a Python developer, I'm talking like making a living as a Python developer, right? And actually having a job, right? This is a product, this is a program that's gonna take you there, right? Through coaching like these, right? Through trainings like these, through a community like this. It honestly does not give it. This is not your Udemy course. This is not any course that you can compare it to. It's completely different. You got the community, you got the training coaching calls, which at this point we have, I think, 2 or 3 coaching calls every single week, right? You have Python success coaches who are there to help you, an exclusive community, Python trainings, and so much more. So if you're at all interested, even just a little bit, like just a tiny bit at all, you're like, okay, this is interesting, okay, here's what I want you to do. I literally want you to click down below in the description. There's a link to cleverprogram.com to this course. Check it out. Even at least check it out. Watch this video. Watch the video with this video right here that we're talking about, right? Watch this video. You'll see what we're talking about. It honestly is such good value. It's unprecedented. Unprecedented? Did I say that right? I don't know.
Yeah.
But anyway, guys, so check it out. Literally go right now. Check out the link. Check it out. If you're interested, get it. And now we will see you in the course, guys. Sweet.
Awesome. So let's finish this game up. We're going to start off strong. We're going to end off strong here. So finally, like I said, we changed the way our game loop works. So now we do the game loop. And when the game loop's done, we display our game over.
Okay.
So this is our display game over function. Right here, I've highlighted for you. So what happens here?
Oh, wow.
We make a font. Yeah, I know there's a lot going on, but it's mostly just making a font on a screen.
Got it.
So we make a font. As you can see, it's game over. That's it.
Mm-hmm.
We make them rectangles. So this is us drawing. This, all it does is draw a game over to the screen.
Mm-hmm.
And then I have a couple helper functions here. So we say we have a draw key press message, and this is used whenever it's used on our menu screen and also here. And if you look on the right, Naz, you'll see a little press a key to play.
Where?
It's very dark.
Right here. It's like very light. I see it. Okay, right here.
So you're gonna see that, and what it does is it calls another function that's called check for key press. And what check for key press does is it just constantly checks our game, and once they press any single button, then it will return. Or it will return essentially and allow us to go forward with that. So let me grab that function real quick. Really simple function. Let's see here. So this is our game over screen. Sorry, one moment here. Where is it? That's our title screen. Handle key events. Here it is. Awesome. Awesome, awesome, awesome. And this is our check for key press. So I'm going to put it next to our handle key events. I'll put it right above it, actually.
Wait.
Line 60 inside of game.
Right there. Okay, I see. Check for key press. Okay, cool. I like it.
And what it does, again, it's, we won't get into the specifics, but it just checks if you press any key. It also double checks if you happen to press escape at any time during this, it'll quit the game for you.
I see. That's cool.
So now here we are. We're running this game.
Let's see it.
We can see game over, and I press a key, and a new game starts.
Oh, would you look at this, guys? This deserves an ear horn, guys. Give us some fire for this. It's pretty much a finished product, a finished game, right? Is it not?
It is. You know what would make it one thing much cooler, though? Just one last little detail that would be awesome.
Yeah. What is it?
I think a menu screen. And I want the menu screen to be crazy.
Guys, who wants to get even more fancier? Let's do this.
I think a menu screen would be the last thing that would be awesome to add.
Let's do it.
And, let's take a look here at our run on line 135. How would we do this, right? We have this true. Well, we show the menu screen one time. Interesting. Why don't we just run a function one time that's called show start screen?
Nice. All right. I like it. Beautiful. Okay. And then we need to import the show start screen, right?
Well, that's right. And so all we need to do, let me grab it here. And it's going to seem like there's a lot going on here. And I'll briefly go over it. But again, it's just making a bunch of rectangles and rotating it so that it's flashy. I'm going to add it right here. And we will go over this code real briefly.
Okay.
So what's happening? Again, we make a title. We say wormy. We render it. Then we have these degrees. The degrees are actually used to rotate the objects. They just keep track of how far they've rotated.
Gotcha.
So then this is our little check key thing. So the second that they press a key, we just return, we exit essentially out of this function.
We're done with this draw screen. Okay, got it.
Exactly. Okay, and then what are we doing here? Again, we're making a rectangle, rotating the rectangle, and then we draw it. We make another rectangle. Again, just making rectangles. That's what these three lines do. And we draw it. Then we draw the key press message function. And that just means, it draws that little notice at the bottom. We update. So this is allowing us to update our display. And finally, and this is, you guys might have noticed we had an FPS and a menu FPS. And the reason we do that is because we want our menu to look really smooth and rotate and not have any lagginess to it. And so I make the FPS 60, whereas our FPS for our game actually controls how fast that we move our snake.
Got it.
Whereas in the menu, it's just how fast we rotate. So I just made that small.
Got it. Makes sense. Okay, cool. I like it. All right.
Okay, so let's click play.
Hold
and
on.
what I want you guys to see here.
Oh man, look at
now
that!
Have a fully functioning app. I click here, I press any button, and I start playing, and immediately lose.
Hold on, guys. Let's see how many Michael will get the most. Hold on, let's see it. Hold on, I'm gonna.
Oh, dude, I did it last night, man. We're gonna be here a while.
Hold on, I'm gonna put. I have this chasing sound effect. It looks really cool. Let's see how much Michael will get it. Let's go, Michael. How do you like my song?
It's kind of quiet, dude. But I feel the vibes.
Hold on. Let's see. Hold on. Oh man. Hold on.
There it is.
Oh, let's go.
And you guys can see there that the body is trailing me. The score is up to date. I keep getting longer and longer.
Oh man. This is getting harder and harder, man.
Yeah, this game is. Dang it.
So 24, 24.
24. And what's cool is I can keep playing or press escape, and that ends the game.
Nice, nice. Man, that was cool. That was a lot of fun, guys. Who thought that was fun? Who thought that was like a really cool game to make and then a cool game to play, guys? So actually, I'm curious. So are we done at this point? Are we pretty much done with this game? Is that it, right?
That's it, man. We've got a menu screen. We've got a fully functioning snake game that lets you play time and time again. And that's it. You can copy this code, work on it yourself, add anything you want to it. Perhaps you could think about, maybe some animations, or I have some long if statements in there. Maybe there's a better way you could do that.
Yeah. And how can they actually go on there and actually play this game right now? Is there anywhere where or do they just go on that site and that's it?
Yeah, absolutely. You guys do this. If you guys would like to play this game right now, go ahead and do this link. I'm not highlighted, Naz. If you could put it in, you're all highlighted and you're fancy, and they'll be able to see that.
Give me the link. Where's the link? Where's the link?
Yeah, absolutely. Let me send this to you
Send me
again.
in Slack.
Yep.
I see now. Ah, okay.
Oh, that's wrong. 1 second.
That's the wrong link.
Here we go. I was missing the E. There you are.
Okay. So they simply run it, right? That's it? They simply just run it?
They run it. It's going to fork it over into their own little project there, and they can code on it, change it, do whatever they want, and they have the game.
Beautiful. So you guys go ahead and click that link, guys. Now, here's what we want you to do. We want you to go ahead. As you're playing this, let us see who can get the highest score. So I got an idea. I got an idea. So play this game, okay? I want you to play this game, guys, okay? And then go ahead and tag me and Michael, right? Go ahead and tag me and Michael in your Instagram with the highest score that you got for this game. We want to see it. We will go ahead and repost your stuff, and this is gonna be a really fun couple. Oh, somebody said 38. Somebody just said 38. Dang, would you look?
Ooh, dang.
They just beat you, Michael. Dang, look at that.
Picture it didn't happen.
Oh man, that's awesome. This is really fun. This was a lot of fun, guys. What did you think about this? Let us know in the comments below. What did you think about building a game like this? Like, this was a lot of fun, honestly. Great explanation, everything,
Absolutely.
guys. Great explanation,
Absolutely.
everything.
And I hope that this gave you guys more than anything a structure to follow.
Yeah.
The next time you're ready to build an app, the next time you're trying to do something, maybe it's a game, maybe it's a website. First, think behavior, then think what doesn't change about this program, then think, okay, the things that do change, how do I represent those things?
Yeah.
And then finally, once that's all done, once you have those three, then the fourth thing you're going to do is write the functions that change everything.
Got it. Yes. Beautiful, beautiful, guys. Well, let's see. What? If you guys got any questions for us before we leave, which we're gonna leave soon, go ahead and drop that in the comments below. Yeah. So yeah, let us know. Let us know if you guys got any questions in terms of development, in terms of Python, maybe profit with Python. Maybe you have a question about the course. That's great too. Let me see. Let's see.
Yeah. And again, about that course, man, we went over a lot of high level stuff today. Thinking less about code and more about how do we implement these things.
Exactly.
But if you guys want to learn the specifics, the step by step, somebody's there to lead you and guide you by the hand and teach you, this is how we code, this is how we're going to do it, this is how we set up our environments. They're going to have projects for you to complete. You're going to have people reviewing your code for you. You're going to have a community of people that you can ask questions with, make friendships with, build and code together. This is what this program is. There's nothing better out there. And I'm not kidding. I did not work for Clever Programmer before I was a student. I was a student first, and it changed my life.
Yeah.
And I know that's a lot to say, but it really did.
Yeah,
I loved it so much I ended up working for them.
I mean, Benjamin, you started what? You started, you did Profitable Shortcut, right? You did Profit with Python as well, right? And then you just kind of got into it, and all of a sudden you are now on a team.
Yeah.
It's crazy.
Yeah. And it's absolutely exciting. I was waiting tables before this, guys. Wow. I was serving food to people.
Wow. And look, I'm actually very curious, like, what got you to actually want to change that? Or what got you to want to change that? I'm curious.
Yeah, well, it starts with a lot of the people on this call are just like me. They want to make improvements in their life. They want to do better, and you can burn out, right? For 20 years, you can keep spinning the wheels,
Yep.
or if you're really smart and you're willing to invest in yourself, right? And not smart like you have to be smart to do this, but you're smart about the fact that you should invest in yourself. Um, you do that, and you have help, and you reach out and help, and the opportunities that are out there nowadays, especially with what we're doing with this company, is just, it's so cool, and I'm so proud to be working with this and with you guys, and helping out the community like this. And I wanted the same thing. I wanted to work towards a better life, and I found Clever Programmer, and that's what happened for me.
He took a chance, he took a risk, and here we go. Sometimes you gotta take a chance, make a small change, right? Make a big change. Not even a
Hmm.
small change, make a big change. And then that's what changes everything.
And it's so easy right now too, guys. Like, I want you to pay attention how easy it is right now for you. There's no better time. Okay? The job market's about to explode for software developers. Remote working is at
Crazy.
an all-time high,
Yeah.
okay? This is the time to start. And you can just try it absolutely for free. You sign up. If you don't like it, you get your money back.
Yep.
So this is an absolutely zero risk. Check it out. Go to the website. The link is in the description. Check it out right
Below.
now.
Yep.
Don't wait. Just click the link. Check it out. There's no better time. There's no risk. This is the best time to learn how to do this. And you're going to build stuff like this. I mean, how cool is that? We just built a game together, like a full-fledged game that really
Yeah.
works.
Yeah.
And now you have the code too. You can update it, change it, figure out what you want to do with it. We're going to teach you all the specifics, all the nitty-gritty details, all the pitfalls, all the things to stop you from banging your head against the keyboard.
Yeah.
So this is the time to do it. Absolutely check it out now. You're going to learn from people like Nas, people from Jacob. It's an incredible community. It's awesome.
Yeah, exactly. And I think most importantly is like, right, you get to learn all the nitty gritty stuff, but at the same time, you get to use the nitty gritty stuff, right? You get to use it
Yeah.
to actually, right, go out there and, maybe you want to become a coach, like, a coding coach. That's the first that you start out with. Then you use the projects that you just built, right? You use those projects now to go ahead and actually, apply to companies like Google, right? Or Facebook.
Hmm.
Or
Hmm.
maybe it's a startup company, who knows, right? But that is your starting point, right? Anything you do is going to be a good starting point, guys. So yeah, seriously, check it out. Michael's done it, right, guys? Check it out. Link is in the bio. What are you still doing here? I don't know what you're still doing here. You should still you should be on that site right now. You should literally just like take that pointer, go description, click that nice link, check it out, and we should be all good. But other than that, that's pretty much all we got, right?
That's it, man.
That's all we got, guys. So it looks like I don't see too many questions right now, guys. Seriously, thank you so much all for watching. It has been amazing to see you all comment and to participate with us. And Michael, thanks so much. This was so much fun. I myself learned a lot, through this process, and I love the process that you just showed to us, right? In terms of thinking very much high level. First, think about the data, think about the process, and then you code it up, which is
Hmm.
amazing. But you got anything, any finishing last thoughts before we leave?
That's it, man. Absolutely. The one thing I'd recommend is play with the code, guys. Have fun with it. It's going to be a lot of fun. So,
Yes, and tag us in your Instagram post.
yes, definitely do that.
Awesome, guys. In that case, have yourself an amazing day. Have fun, and we will see you in the next video. Peace out.